Yo, testing 1 2 3, testing 1 2 3, testing. I believe we're ready to come back online, if I'm not mistaken. Yo, what's up? Welcome back to Vencabot. Intro to Python action. My name is David. Today we are going to do our last adjustments to our Pokemon example here before we move on next week to a new project where we're going back to the very, very basics of Python, the like day one notepad, never programmed in your life kind of stream. In this case, though, we're going to be the most advanced we've been yet. We're going to be looking at classes. In particular, object-oriented programming, how we can use that to our advantage to make our Pokemon script as cool as it can be after 6 short sessions of programming. Before I get started, guys, we are enjoying the music of my friend Aubdat. That's A-U-B-D-A-T, as you can see right here. You can get all of his music for free at aubdat.bandcamp.com. Very cool stuff. Get it in FLAC format, get it whatever you want, MP3, WAV file. It's very high quality stuff. Awesome music for programming too. Helps you keep your concentration, at least it does for me. Good for focus, good for homework, good for that kind of thing. Puzzle games, perhaps. You guys remember Tokitori here? Very cool guy. He's also at TC640B on Twitter. That's at TC640B. Very nice guy as well. Go check out his music. It's really, really cool. Yeah, let's look at our script so far, guys. Our script so far is our Pokemon Day 6. It's our 6th day of programming with this Pokemon example. We started off, again, as though we were total beginners. We had never programmed a day in our lives. We talked about variables and operations, right? Data and operations, how those are the two halves of programming. You have things you want to get done, which are the operations, and then you have the data which you need to complete those operations, right? So half of your work is collecting and constructing data. The other half is operating on that data, oftentimes to make new data. We talked about conditional statements, like if statements, about blocks in general, right? About how usually in programming, you go straight down from top to bottom with your instructions, right? It's like a list of instructions, basically. Every line is a new instruction for your computer to run for you. But you can sometimes indent those lines, what we call blocks. And blocks only run under certain conditions, which is to say, like in this if statement here, right? We indent this code here because this code only runs under certain circumstances. If this is true, then we do this stuff. If not, we skip it. We talked about, if, else, elif. We talked about for loops, while loops. What other blocks do we know of? Functions, function definitions are blocks that only run in certain cases, which are to say that if you call that function, that code will run. And now, more recently, we have classes, right? And classes, they address both the data and the operations halves of our code, right? Because classes themselves represent an object that is itself data, right? Like a Pokemon, for instance, right? We're talking about what is a Pokemon. Well, it has these attributes, right? That's all data for us to use. We also have methods, right? Like this use method here. That's an operation. So we have a class. You can define some data and some operations that all relate to one concept. Now, at first, we were reluctant to address classes because it's kind of a more advanced topic. So we kind of strayed away from that for a long time. Now we're finally kind of tipping our toe into it, and we're learning about how important and powerful classes are. And the most powerful thing about classes is that when you exercise inheritance, as we do here with Pokemon Move, right? We define this Pokemon Move as a class, and then we inherit from it. That means that now we can use these Pokemon moves similarly, right, in our code. We can swap them in and out. And when you can swap data in and out and then do similar things to it, but have different things actually happen in the end, that is a very, very powerful tool in programming. What's up, Locust? Locust was here stalking me before the channel even got started today in the chat, talking about Third Strike. We're big time into Third Strike here in this channel. That's Street Fighter 3 Third Strike, but we only do that Monday through Thursday. Today it's Casual Friday. We do more event-type stuff, special event-type stuff, and that means starting off with programming every Friday. And this evening is going to be some Sonic R, a Sega Saturn game from my childhood that I love dearly. Although we haven't really gone much into depth about why you'd want to use classes, why are they so powerful, in terms of like swapping them in and out, we have at least discussed what they are and how they work, right? We learned about this period symbol here, the dot, which is apostrophe S in English. It means ownership. Right, so we have a dot that means, ourselves nickname, ourselves monster type, right? Likewise, down here we can say Pokemon 1's nickname. We can use that, right? It's an attribute. Basically, when we say it's an attribute, it's a variable that belongs to that class. What's up, Kenny? How you doing, dude? Welcome aboard, Home Slice. as compared to this variable here, user input, right, which is just a floating variable. It doesn't belong to anything in particular, it's just out there in the ether. Whereas a nickname here actually belongs to this Pokemon in particular. Likewise, we also use the period to summon random.choice, right? This is the choice function that belongs to the random library. And up here you can see we import random. And we talked very briefly about libraries last time and about how Python itself has a lot of built-in functionality. Right? It's functionality that as soon as you open up the box, you have all this cool stuff you can do. But also on top of that, it has code that belongs to libraries, which are tool sets basically that you can bring into your program at will. Now maybe you couldn't do it normally without importing, right? You have to actually manually pull in those tools with the import command right here. But if you do import that stuff, you get all kinds of cool stuff. You can get new classes, you can get new object types, that's like data types. You can get new functions such as random.choice. And it's very powerful. If you want to learn about libraries, guys, you can go to docs.python.org. Right here, docs.python.org, and then click on library reference. And here's a big list of all the libraries that come built into Python. Again, what I mean by built in is I mean that you can import them without having to download anything else. When you download Python, then you can import all these libraries at will. You can learn about the built-in functions, right, and the built-in types, which is very, very cool. But also you can learn about other cool things you can get by importing, like by import string, import re, import difflib. You can also import random like we did right here. And other cool stuff like numbers and math and you know, operating system type stuff, file inputs, all kinds of cool stuff to import there. But we're not going to fuck around with that right now. It's more advanced. You'll learn that as you become more mature as programmers. Kenny's doing pretty well, huh? Been trying to sit down and watch some videos about why OOP is bad. Just curious about that perspective. It's if you watch the right scholars, Kenny, you will see that it is a very valid argument. I mean, functional programming is great, man. I think in the past I haven't really stressed that enough. I kind of spun it for the sake of beginners as kind of like a loopy kind of idea, right? Because I wanted to help people understand that, especially for beginners, object-oriented programming is very, very important. But no, dude, functional programming is fucking great, man. Functional programming is great. It's just as powerful as object-oriented programming. You don't need classes and stuff like that if you want to become a really good programmer. And functional programming will make your code less buggy in the long run, probably. But at the same time, a lot of these guys will tell you that classes are the devil, right? The classes and objects are the devil. You don't want to fuck around with them. I don't subscribe to that notion at all. I think that classes are super important, if for nothing else, than to make your code more understandable by a human mind. Right? I think it's really, if I were to give you guys one lesson about classes, it's that the most important thing about classes is that it helps you take an absurd amount of data that modern programming requires. Right? If you want to make your own game or make your own you know, server, make your own whatever kind of software, it's going to require a lot of data and a lot of functions, a lot of crazy shit going on. And the really cool thing about classes is that when you can say these variables, all this data is attached to this notion, right? These are all attached to this notion, and all these functions are all attached to this same notion. These all are related in some way. Put them in all class, they're all related. That is such a powerful tool for organizing your code and helping you understand it. Like in our case, we have, like, you know, all this stuff about a Pokemon, right? His HP, his attack, his defense. That could all sure just be loose data in the ether. Listen to these guys. Thank you, guys. It could all just be loose data in the ether, right? But because we can attach this data to a Pokemon, right? This thing that we've created, this idea of a Pokemon. And likewise, we can think of that Pokemon as using a move, right? This idea of this Pokemon, he has a move, right? It's one of his attributes. He has this move, and then he can use that move. That's pretty easy to understand, right? As a player, somebody who's played Pokemon before, right? It's pretty easy to understand. Whereas in functional programming, you kind of have to do some mental gymnastics a little bit to understand how the code works. And that's fine if you're the guy that wrote the code, or if you're really, really competent at functional programming. That's cool. There's nothing wrong with that necessarily. That being said, a really cool thing about classes is that it helps you understand how your code works. Again, it's very important for beginners. Definitely, if you're a beginner, do not fuck with functional programming, man. But look it up later for sure and decide for yourself if the benefits of using classes outweigh the damage they can do to your code. And we talked before about how using classes and any what we call mutable data is very dangerous. Now, not only are functional programmers against using classes and objects in that respect. But really what they're trying to get at is that they're against using immutable data. Let's talk about that real quick, guys. Let's talk about mutable data. I'll make a new project here, right? We're going to call this, you know, mutable versus immutable. Let me actually line that up. I'm so anal about that. Here we go. Let's save this as, you know, mutable versus immutable, right? Now, we talked before about, well, I should say a long time ago, in fact, about the idea of what is a variable versus a literal in not only Python, but programming in general. What is a literal? When I say a string literal or an integer literal or anything like that, what am I talking about? I'm talking about the difference between saying, let's just say, you know, my int equals 2. It's an integer. Why is it, where's the syntax highlighting? And then I can say, you know, my value, you know, let's just say my sum equals 1 plus my int, right? Then print my sum. Let's save this. And let's run it with F5. Actually shrink this down. Like this, we can have it on screen more often. Let's do it like that, in fact. Okay, move it around down here. We'll keep that window open from now on. Okay, so we're talking about literals versus variables, right? So we have this my sum. As you can see here, we have a name for it. It's called my sum. That makes it a variable. You can see the little assignment operator here. We're saying this idea of my sum, make it hold this data. Whatever data is returned by this operation. We have an operation here, 1 plus my int. Whatever data comes back from that, store that in this name, my sum, right? Likewise, my int is a variable. And we assigned it not via an operation necessarily. There's nothing really happening here, but we just have this thing 2, right? We could have it be an operation like 2 plus 1 or whatever, or 2 plus 2 or whatever you want to do. But in our case, it's just 2. It's just 2. But what's interesting about this is that my sum, it is dependent on whatever my int is equal to. My int is a name that points towards something, right? The name points towards something. In this case, it points towards 2. Likewise, my sum is a name. It points toward wherever this ends up being. But that means that, let's say we also have, my, how about, my multiplication, whatever, my mult, we'll call it, right? We're going to have this be 3 times my int, right? Let's print off some more stuff here. Let's print off my mult as well. So we're going to print off, print my sum is, right? And we're going to print off a blank line here. We're going to say, my mult is this, right? So let's run this code now. That's kind of more of a day one kind of thing here, but I think it's important we kind of review this real quick. Okay, so my sum is 3, right? That's 1 plus my int. Then we have my mult is 6, right? That's 3 times my int. All right, well, that's cool, but what am I getting at here? Well, I'm getting at, in both of these operations, we are relying on whatever my int is equal to, which means that we can change both of them by only changing one line of code. Just by changing this to a 4, we can actually change both of these lines down here. And that is something you take for granted as a programmer, but it's unbelievably powerful, right? It's something that seems so simple. But just by changing this one line, we can change an indefinite number of lines in our code. Not just 2, not just 4, but hundreds sometimes, right? And in fact, often hundreds of lines can be changed by just changing the value of this variable. Now my sum is 5 and my mult is 12, because both of these operations are referring to my int, right? And we define that right here. So a variable is a very powerful thing, and its value changes over time, right? And that's really cool, but can cause problems. The fact that the value can be changed, can cause bugs in your code as you become more of a stronger programmer, and your programs evolve from being 100 lines to 500 lines to 1,000 lines to 50,000 lines of code. Having things that move in your code, parts that move and change, and what they say they're called mutate, right? Things that mutate in your code, that can cause bugs because you might expect this value to be this value right now, but for some reason that you have lost in your 100,000 lines of code, right? For some reason that you've lost track of, this value is not what you think it's supposed to be. Why is it changing now? You know, why is it changing now to this value? That makes no sense to me. You have a bug that's very hard to track down. Variables are mutable. They can mutate, right? Whereas a literal, right? A literal is a piece of data that never changes. It is just this thing. You can see it very plainly on your screen what it is. This is a 4. This is an integer literal, right? It's always 4. No matter what, it's always going to be 4. A string literal, you know, you could have my string, right? That equals this, you know, this is a string. When you have a string that has quotation marks around it like this is a string literal, right? When I say a literal, I'm talking about the data that is not a variable. It is just the data. And you could have, let's just say, my original sum or whatever. Let's just say my literal sum is 2 plus 8, right? Now, these are both literals. You have an integer literal here, a 2, and an 8, also a literal. But this itself is an operation, and it's the lingo we use in programming is it's something to evaluate, right? You evaluate this, and it gives you back a number, right, which would be 10 in this case. But there are some types of data that are inherently and powerfully mutable in Python. You have integers, and although you have this string, you have this variable which is itself mutable. You know, the variable can be changed to whatever. It can be a 4, it can be a 5 or a 2. But the integer itself, number 4, that's not mutable. It's always a 4. Likewise, this integer here is always a 1 and a 3. You cannot really change an integer to anything else. It is always an integer. We could change my int to be a string, confusingly, right? This is a confusing string, right? Because this any variable can be mutated, of course. A variable can be mutated, but the actual data type that it points to, the integer, it cannot be mutated. Likewise, you have things like strings. They cannot themselves be mutated. Let's say I want to say, my new string equals hello there plus Kenny, right? You have 2 string literals here, and you are combining them, right? So you're getting a string back, but neither of these strings is changing. They are being utilized. They're being used in an operation, but what you're getting out of it is a new string. You know, whatever you get out of this, whatever you get, hello, let me put a comment here, you get hello there, Kenny, right? This is the string you get out of it. But this string is a brand new string. Just like when you add 2 and 2, you get a 4, but neither of those 2's themselves changed. You just get a new integer back, which is a 4. But there are some things that actually do change, some data types that themselves change, like a list. My list equals, red. We talked about the color list before, right? Blue, yellow. You have this list, right? This is a list, sure. But if we were to say, my list dot append purple, now we have a new list, right? This gives us a list that is like, red, blue, yellow, and purple, right? But as far as Python is concerned internally, it is still the same list. We talked before about this string right here, how we add 2 strings, we get a new string, right? We add 2 integers, we get a new integer. But with a list, if you add something to it, you don't get a new list. It's the same list. It just has something new added to it. And that can cause bugs in your code. Because at one point you think, oh, this list has this many things in it. And then later on you find that same list has a different number of things. That can be confusing. It can cause bugs. It can be hard to diagnose why it has more things or less things than you expected. And it sounds very simple, guys, but trust me, I've had so many hours of my life spent debugging problems just like that. I'm kind of oversimplifying it for you guys to make it more simple for beginners, but it is a problem when data changes and you don't expect it. Likewise, dictionaries are the same way. Dictionaries are mutable data types. They can change over time. It's the same dictionary as ever, but you can add things or move things, change what certain keys point to, and such like that. And finally, any object that you make from a class, that is a mutable object. It has attributes that can change. So you would say that it's a mutable object. And objects such as integers and strings and tuples, or tuples, however you want to pronounce it, those are immutable data types. They can never be changed. Those things are just set in stone. And if you want something that's different from that, you have to make a new one. I mean, let's say I have a tuple, right? Let's just say my tuple. It's going to be, red and apple, right? I can use that tuple to make a new tuple if I wanted to. Let's just say, my tuple is that, we'll say first tuple, right? We'll say, first tuple and second tuple. So we have this first tuple, it's red and apple. Two pieces of data that are related, you put them in a tuple. We also have a second tuple, right? And it'll be, yellow and banana, right? Also two related pieces of data. But if you want to, let's say you want to have like a yellow apple, right? You want to use both of these tuples to make it for whatever reason. We have a third tuple, right? And that could be, it could be based on the second tuple, its first index, which would be yellow. And we can also base that on the first tuple's second index, right? Which would be apple. Now we have this third tuple, and it is actually like this. It will say yellow and apple. But it is itself a brand new tuple, right? It's based on two previous tuples, but it's a whole new thing as far as Python is concerned internally. These would both be hypothetically discarded, right? We don't need these two anymore. But we have this third tuple now, which is based on those two. But you can never, ever change these tuples inherently. Once they're made, that's it. There's no way to add more things to them. You can't suddenly change this to be, red, apple, delicious or whatever, right? You can't, you cannot change this tuple. You could make a new tuple. Again, we could make a new tuple again. We could have like a fourth tuple, right? We could have a fourth tuple. And that could be, first tuple's 0th index and first tuple's second index, the number 1 index. And we could also have, delicious, right? We could make a tuple that is based on the first tuple, but we can never take this first tuple and change it. We have to make a brand new one based on it. And functional programmers, that's what they love. They love, if they don't need this data anymore, to get rid of it. If you want new data, you make that new data on the fly. You create that new data and you get rid of the old shit. You don't ever change anything, because once you start changing something, you can have bugs that crop up. And we talked before about how classes and the objects they create are themselves inherently mutable objects. They change all the time. In fact, in our Python and our Pokemon code, you can see it happening. Yeah, tuples are immutable, Kenny, yes. Lists are immutable. They can easily be added to or removed from, and you still have the same list. It's just different now, but it's the same list. Tuples are immutable, and that's why you oftentimes will see functional programmers use them instead of lists or objects. They like tuples more because they can never be changed once they're made. But yeah, so in our example here, right, Pokemon, they have an HP value, right? Now, when this Pokemon gets tackled, right, it gets fucking tackled, right, his HP goes down, he loses some health, but he doesn't become a new Pokemon, right? In functional programming, he would become a whole new Pokemon. Whenever you lost health, you would make a new Pokemon whose HP is a different value than it was before. But it's, as far as the programming is concerned, it is a new Pokemon entirely. So you would have your Bulbasaur get tackled, and then that Bulbasaur would just vanish into midair and instantly be replaced by a new Bulbasaur who is the same in every way except that he has lower health, right? But he would be a new Bulbasaur. Whereas in our case, if we look at our code for tackle, let's look at this code for tackle right here, right? It says that the target's HP is changed to whatever it was minus the damage that was done. So if it was, let's say that it was 5 when we did 4 damage, now he has 1 HP, as his new HP amount. But it is still the same Bulbasaur. His HP has been lowered. So Bulbasaur is a mutable object. He changes. Parts of him change. What's up, Dix? Says, why tuples? Why not ooples? I kind of like your idea more, Dix. That'd be more fun to say. Making some ooples. I don't know why it's called tuple, or if I'm not sure even how to pronounce it. If it's tuple or tuple, I would say tuple. In my head when I'm doing it. Yeah, I don't know. Tuples, I don't know, kind of just the name itself kind of implies. Also include a quadruple. Then yeah, tuple. Is that why it's called a tuple? A tuple, a triple, a quadruple, maybe. It's pronounced like the tuple in quintuple. I say quintuple. I guess maybe it's tuple, huh? How you doing, Dix? How's your Thanksgiving, man? Oh no, you're Canadian. You don't celebrate American Thanksgiving. Well, I hope you had a good day anyway. I ate a lot of delicious food. I had a lot of stress though afterward. I had to fix my mom's phone, which coincidentally died during Thanksgiving. It was a huge pain in my ass. But it was, it's more or less resolved now, thankfully. So this is exactly why functional programmers stay away from classes and objects, because Bulbasaur's HP in a program, I mean, our code is like, what, like 100-some lines? It's very, very simple code for, you know, we're kind of beginner programmers here. But one day it could be, you know, 100,000 lines. And one day you might find out that Bulbasaur's HP is changed, and you don't know why. You're like, why did his HP change to this? It should have been that. That makes no sense. Now you got to go through countless lines of code to figure out why this guy's HP changed, because it could have been changed by something that's the last thing you expect. Right? And that can cause problems. In fact, it often does cause problems. So some guys that grew up, like me, having to solve these bugs on the regular, one day they said, fuck it. Why even use these fucking classes? All it does is cause problems. I'm going to just never use a class again. And, of course, they give up all the power the classes have. But they also get new power by functional programming. Functional is a really great way to program, guys. I don't want to sell it like it's a bad way to program. It's really cool, but it is a very different thing. It's based off of using n tuple as a broad any number of integers thing. Okay, I got you. I got you. But does the word tuple itself mean, like, what's the word for when you have two? A double, right? A double, triple. Okay, so the tuple, I see n tuple, I guess. So, you know, you have a quintuple, a triple, quadruple. So tuple, I got you. Okay, so now we've gone a little short rant about mutable data versus immutable data, and why certain programmers choose to never fuck with mutable data, because it can cause all kinds of problems. Let's focus again on object-oriented programming as beginners. We're going to pretend that functional does not exist. We're really focusing on learning how to program with classes and objects. And I just want to stress before we move on, I guess, that when you do change a class's or an object's data, one of its attributes, do so responsibly. Do so in a way that's very sensible. And as you become a stronger programmer and learn about best practices, you will learn what that means to do it sensibly or do it responsibly. As beginners, you're going to have pitfalls. Trust me. You're going to be changing your data, thinking it's all well and good, and then it's going to cause problems for you down the road. But you will learn over time what it means to change data responsibly and sensibly, so that when something does happen, you do reach a bug, you will be able to find it quickly. You'll say, oh, well, that's why that bug happened, because I changed this thing back there. Okay, that makes sense. But if you do alter data in a way that isn't necessarily, its logic is not very clear, like why you did it, then it's going to be very hard to solve that bug later. Trust me. Okay, so, yeah, we're going to look at our code here. Very simple. We've got a couple of Pokemon we've defined that extend Pokemon. Right? We have this Pokemon master class. Right? It's a class we made that defines a generic Pokemon. It has all the generic Pokemon stuff you need to be a Pokemon. But then we also have these classes that extend or inherit from Pokemon. And they themselves are more specific, but they still have all the stuff that Pokemon has, just that they've got a little bit more. Or in this case, they've got a simple init function that automatically defines some of their stats. If a bug happens, just press Control-Z until it goes away. I don't know, dicks. That's a good idea. That can cause problems, too. Programming can be very complex sometimes. Okay, so aside from having some classes, we got a few moves. We have basically 3 main classes in our code right now. We have a class that defines, when you run out of PP, you have an error, right? Your PowerPoints. You get an error message if you're out of PP. That's one class. It extends that exception. We also have 2 other classes that are Pokemon Move, which are like moves that Pokemon can use. And then we have a Pokemon, which is the Pokemon itself. And then we finally have a little bit of some subclasses, some classes that inherit from Pokemon Move, a couple moves, so to speak. And then some Pokemon, Cyndaquil and Machamp. What's up, Kenny?
Hey, Venga.
In fact, we did, Kenny. We already fixed that error. So last time we finished our day 5 Pokemon code, we had a much simpler enemy AI. And what it would do is that it would pick a move at random, and then it would use that move, right? But what I did not remember, what I didn't think of when we ended that stream, was that we had just before that implemented this PP error idea, right? So now when an opponent, or when, let's say when a move is used, and it has no PP remaining, we have this message right here. If, this is when the move is used, right? See, it's a method called useOn. It takes a target, and the first thing it checks is if it has any PP left. If this move, self, has any PP remaining, it has to raise this error. right? And when you raise an error, it causes your program to crash unless you catch that error. As you can see down here, when it's our turn, our Pokemon's turn, we try to use the move, but we catch the PP error if it occurs. We accept the PP error. And if we do get it, we just print a cute little message here to tell the player there's no PP remaining, and then we ask them again for a move. Right? Makes sense. However, what I didn't think of last time was that when the opponent chooses a move at random, he doesn't think about if it has PP or not. And if it has none, it raises PP error, of course. But there's no try except block. So that will just cause the program to crash. Right? And that was our problem we had. Thanks for shout out to my friend Carbanoid, Carbon12, for recognizing that bug after the stream was over. We ended the stream and he messaged me about this bug. And since then I have fixed it. I'm going to tell you about how we fixed it. What's up, Zanzu? Hey, what are you playing, man? I'm doing great, Zanzu, personally. What's up, Bootcamp? Shout out to the developers, man. It's a lot of work. Does the PTR have major updates, or is it just a bunch of balance patch things? Huh? PTR, what did I miss? Oh, because PTR. Oh, I see it in Diablo 3. Oh, okay, talk about Diablo 3. That's what Zanzu's been playing. I gotcha. Yeah, so here's what we did to fix our opponent's AI, so that it wouldn't pick a move that had no PP, and then crash the program. So from now, when we get to the opponent's turn here, right, if the opponent is still alive, he gets a turn, right? This says, if Pokemon 2's HP is greater than 0, if he's still alive, he gets a turn. The first thing we do is we make a list of available moves. And that list is empty, right? But because lists are mutable, they can change over time, for better or worse, that means that we can add things to this list. We start off with an empty list, but we can change that, right? We can make it a better list. Excuse me. So what we do is we make this list of empty list of available moves. And we have to populate that list with moves that can be used. And not every move can be used. If it has no PP, we can't use it. So we say, hey, listen, if this, for every move that the Pokemon 2 has, right? So for every move instance inside the Pokemon 2's dictionary values, and the move dict is a dictionary where we map the move's name, it's a string, to its actual instance of the move, right? So we map the word tackle to the tackle. Right. So for every move that the Pokemon has, we do a little if statement. We say, hey, listen, if that Pokemon's name is Dicksucker, right? If that Pokemon's nickname is Dicksucker, and the move in question is Comb Hair, just continue. Just skip the turn. Right? Because Dix will never comb his hair. We discussed that last time, right? Dix will never comb his hair. So that means that this move is not available to him. When I say continue, now we talked before about continue, right? We described it before as looping back to the top of a while loop. Right? If you have a while loop and you continue, then it'll go back to the top and reevaluate from the top again. However, that's not entirely true. Continue will do that same thing for any loop, and it always refers to the loop that it is in, right? The loop that it is most local to. So although this continue is within a while loop, right? It is first and foremost within this for loop. So this continue here says go back to the top of the for loop. In other words, skip this move. So we say, hey, listen, if this Pokemon's name is Dicksucker, and if our current move in our loop is Comb Hair, then just skip it. Right? Just go to the next move, because we can't use Comb Hair. Yeah, nested loops, Kenny, exactly. These loops are nested. We have a loop in a loop. And the for loop, what a for loop does is that instead of going until a condition is not true, right, the while loop will keep on going until its condition is no longer true. A for loop will go through every item in a list, right, and it uses that list item inside its code block. So we say, hey, listen, for this move in this list, do all this stuff for each move. Right? So hey, we say if that move is Comb Hair and the Pokemon's name is Dix, skip it. Otherwise, we say if the move instance has PP greater than 0. Right? So if the move has PP greater than 0, then we say available moves, which is this list, append our move. Right? So if the move has PP, add it to this list of available moves. Right? So we go through every move the Pokemon has, and we do these tests to it. So if the move, the Pokemon's name is Dicksucker and the move is Comb Hair, then we don't add it to the list. If the move has current PP that's at or less than 0, we don't add it to the list. Right? So all these moves that are have no PP left, they're not available anymore. They're not in this available moves list. Thanks for the follow, Espelon Xtau. We do programming here on Fridays. We're a gameplay channel mostly. We play games for 5 nights a week, But on Fridays, we do some programming here as well. Yeah, it's an inside joke, Kenny. That's because in the last stream, we had this move comb hair, and Dix explained to us that he would never use comb hair. So we had this little line of code here to make sure he would never use it. So yeah, now we have, after this for loop is over, we see what available moves is looking like, right? Because it's actually changing. It's a mutable, it's mutable data. So it is inside this loop changing, right? It starts off as an empty list, but in this loop, it could have who knows how many things inside of it now, right? It's being added to right here, right? If the move has PP, then it gets added to the list of available moves. Now we say, hey, listen, if the length, we have this function here, it's built into Python, len. Len is a function that takes one argument, which is a list or any other kind of iterable data type, and it gives us how many of it, how much is in it, basically. So length on a list gives you how many items are in that list. So hey, listen, give me the length of available moves, and if it is equal to 0, let's just say that all he had was, let's say his name is Dix, and all he has is comb hair and a move with no PP in it, right? That means that it looped the loop twice, and both times it failed, right? Both times it just never added anything to the list. So it's still an empty list. If this list is still empty, if the length of available moves is 0, then print off a message saying the nickname of Pokemon Intu's nickname Dicksucker, the Cyndaquil, right? Dicksucker the Cyndaquil has no available moves. Then continue. That ends his turn. This goes back. This is a continue for the while loop, right? We talked about how the continue statement will jump to the top of whatever the most immediate loop is. So here we have a for loop. So this one here goes back to the top of the for loop. This one down here is not in a for loop, right? From its indenting, you can tell, right? So what is it in? Well, it's inside this while loop. So what we're saying here, and this while loop represents the Pokemon's turns, right? So we're saying, hey, listen, if this Pokemon has no available moves, just tell the player that, and then that character loses their turn. But there's no turn to take. It has no more moves. Wait, that's the reason why? I thought it was because you were doing some coding nonsense. I think that it helps us understand some programming here, Dix, but yeah, that's why you don't use comb hair. Because you never comb your hair. Yeah, that's kind of a fun way to give your Pokemon more AI, Dix. We're talking about AI a little bit here, right? Dix's Pokemon has a little bit more advanced AI. There's a certain move he will not use. And that's how we did it. We did it by checking the Pokemon's name, and then we said, hey, listen, if it's this name and this move, don't use it. Right, but if it's any other name, they'll use it just fine, because only Dicksucker won't comb his hair. Any other Pokemon will comb his hair. Okay, so we're saying, if they have no available moves, then skip their turn. Continue. Just go right back to the top of my turn. Right. But if this does not get triggered, this if block, then we get down to here. We say random move is a random choice from the list of available moves. Right, so if there's any moves in that list that can be used, we pick a random one, and then we use it. Right here, right? Random move.useOn Pokemon 1. And useOn, it's a method, right? Whenever you have an object, like a random move, which is a move object from this list, then you can use its methods with the apostrophe S here, that period. So what's useOn? Well, let's go look at useOn real quick. Well, useOn is a method that every move has, right? It's defined right here in Pokemon Move, but it's also overridden right here in Tackle. So tackles have their own useOn, which runs the tackling code on a target, right? It runs this tackle code. It reduces the opponent's health, basically. And comb hair also overrides useOn. And it just prints a message off, just about them combing their hair, basically, right? It says that, Zanzu, the Cyndaquil, combs its hair, right? And then it uses up some PP. Because every move does in Pokemon. So, and if you don't override useOn, it just inherits the one from its parent, Pokemon Move, which is a simple print. It's a little print statement. It just prints off some data. Right? It just prints off so-and-so, the so-and-so, like Zanzu, the Cyndaquil, used the move on so-and-so. Right? Very simple. If you don't override useOn, just print a message off. Real basic. But guys, I just realized a way we could talk more about the power of classes, right? Classes are primarily a way to save lines of code. Now, one thing we can say for sure is that every Pokemon move, when used, will have its PP reduced, right? And every time it does, it'll always be by 1. So in Pokemon, a move will have some amount of ammo. It'll have like 10 PP, right? That means it can be used 10 times. Whenever you use that move, that number will be reduced by 1 always. So why do we have this line right here? It says current PP equals current PP minus 1, right? That makes sense. But also it's repeated down here, right? So at the end of both of our moves, we reduce the PP. And likewise, at the start of each move, we check if it has PP, and if not, it raises a PP error. That's true of any Pokemon move, right? Any Pokemon move, once it has 0 PP, you cannot use it. So why are we wasting all this time doing that for every move we make, right? Every move is the same, so we can actually just simplify that, right? If they're all the same, don't do it every time. It's redundant. Here's what we're going to do. Instead, we're going to go up here to our parent move, Pokemon move, and we're going to redefine how use on works. Okay? So we're going to redefine use on to, instead of doing a print startup, I'm actually going to get rid of this function altogether for now. I'm going to get rid of that function altogether for now. Instead of printing a startup, it's going to simply do this. It's going to say, hey, listen, if self.currentPP, self.currentPP is 0, then raise PP error. And then it's going to do this. It's going to say self dot take effect, starting with an underscore. I'm going to supply it with a target, the same target we were given for our use on method. Right. So we're going to use this currently non-existent take effect method. Then we're going to say self.currentPP equals self.currentPP minus 1. Then we're going to print off how much PP we have remaining. And we're going to say print, self.moveName plus has plus, the string version of self.currentPP plus remaining with a space. So if you guys were here for our first streams of Pokemon, you guys know that you cannot add an integer directly to a string. You can only add strings together. So because a current PP is an integer, we have to make a string version of it first. That's what str does. That's all it does right there. So we're making a string there to add to the other strings here. So let's just make this a little bit nicer in terms of not being too long to the right. Don't want to go off the screen there. And there you go. So now we have this new useOn method. And what it does is, the first thing it does is it checks if there's PP left. If not, it raises an error. Then it does something. Take effect. This method does not exist yet, right? This take effect method. We haven't made it yet. But it does this, whatever it is. And then it reduces the PP. And then prints off this message about how much is remaining. That's everything. So every move now does that. But let's define this take effect method now. Def take effect. It needs self and a target. And now it's just, all this does now is it just, by default, it just prints a message. Right, we're going to say self.owner.nickname plus, used plus self.moveName plus on, the target's name. A target.nickname. Right, let's actually break this line. It's a pretty long line here. Let's break it up. Okay, like right here. There you go. So now we have useOn, and useOn has this generic thing that it does. Right? What it always does is it checks PP first, then it runs this method, take effect, and then it prints off this statement. It reduces the PP at the end, and then prints off a statement about how much is left of the PP. And then now we have to assume now that every Pokemon move has this other method called take effect, right? And what this does, this is where the actual move happens, so to speak, right? So when you use useOn, it checks PP, then uses the move, and then reduces that move's PP, right? And the reason why we have take effect and we start off with a underscore, that's code in Python. That's like a secret lingo among programmers. That means this method should only be used by other methods inside this class. And it's not a hard rule. It's like it's just a way for programmers to communicate with each other, right? So we could use this anyway. This method is like excuse me. This method is the same as any other method. Starting with underscore doesn't do anything. But what it does mean is that it means only use this within this class, please. Right? It's just it's asking nicely. Please only use this method in this class. That means don't just, if you have a Pokemon move, exactly, it's a guideline for programmers, Kenny, right? It's a guideline. What this means is that if you have a Pokemon move, don't call that move's take effect method, right? Just don't, please don't. Instead, use on, because use on is more sensible. It checks PP, it uses the move, and it reduces PP, right? There's no reason why you want to do that without, you wouldn't want to use a move without checking its PP in your Pokemon game. That makes no sense. So only use this inside this method, right? If you want to use the move, use on instead. Because what we can do now, guys, we can actually go to our old use-ons and replace those with take effect. Okay, and we can remove this code here where it checks for PP, and remove this code down here where it reduces PP and prints off a message. Right, same thing for comb hair. Right, we're going to change this from use on. We're going to override take effect instead, and we're going to get rid of the check. No more checks anymore. No more PP reduction anymore. Boom! We just saved, like 6 lines of code. Right? Because now we would never override use on. Right? So because these Pokemon moves, they inherit from Pokemon move, they inherit everything this class has, they inherit use on. Right? And from now on, use on is itself, even in the Pokemon move, even in the parent class it's called, it is fully functional. Right? We don't want to override it anymore. It's its own thing. It's cool the way it works fine the way it is. Don't override it. However, we do override take effect. So every move, every Pokemon move has a unique take effect method. Right? We always override this most of the time. We'd want to override this. So we override it right here, and we override it right here. But use on always stays the way that it is in Pokemon move. And it's very simple. Like I said, it just checks PP, then it takes effect, and then it reduces PP. So now every move we make from now on is that much simpler. We can make hundreds of thousands of moves, hypothetically. We can manufacture them indefinitely. And now every one we make can be simpler. It doesn't have to do this shit before and after anymore. That's fucking cool! That's fucking cool, right? It makes your code a little bit simpler. All using the power of inheritance. Right? Because now every Pokemon move has this use on, but we don't gotta make it anymore, right? You don't have to override it here. It has it from a Pokemon move. Cool beans, those, man. Cool fucking beans. I was thinking about that before. How what a waste of time it is to check for PP and reduce PP after every move, when you could just have it be done automatically. Sweet. So, what else can we do here today? Well, I'm thinking what we could do is we could, first of all, let's make some more moves. Right, we have 2 different Pokemon types, Cyndaquil and Machamp, but Comb Hair kind of sucks. It's a pretty lame move. So, I mean, Tackle's cool and everything, but it's not as cool as let's say like a Flamethrower. Actually, it's based on types. If you use Flamethrower, if they're a grass type, it does extra damage. We could also have like Growl, which reduces a Pokemon's attack or something. Let's get some more moves in here. So why don't we, well, first of all, I have an idea we can talk about. We can talk about packaging. I want to stress, guys, this is our last stream for Pokemon. We're really more of a beginner-focused stream here for programming Python. But today we are at the very last stream of Pokemon, and we're looking at more advanced concepts, more intermediate type stuff. And don't get scared off. Come back next Friday. We're starting a whole new project. It's going to be way back to basics, way back to basics. But today it's going to be more advanced. And one of those more advanced things I want to talk about is packaging, which means that we can actually make our own libraries. We talked about libraries before, right? Like random is a library. We can make our own libraries and then import them. That way we have this really long document right here. It's like a really long document. We can make it shorter and easier to read by moving things into their own libraries. Because right now it's kind of hard to read. It's just so long. So why don't we make a new let's see here, new file. Okay. And we're going to call this Pokédex. Save as Pokédex .py. Okay, now we're going to go over to our other code. Let's go back to our Pokemon Day 6. And we're going to copy the class Pokemon and Cyndaquil and Machamp. Okay, we're going to move them all over here into the Pokédex. There you go. Save it. Then we're going to make another document. New file. We're going to call this one like move list. Save as like how about Pokemon moves? Save as Pokemon moves.py. Right, now we're going to go back here to our other document. Actually close this mutable versus immutable. That's garbage. We're going to go back to our Pokemon Day 6. And we can get rid of this now. Get rid of all the Pokemon we just had. And we're going to copy all of our moves, including Pokemon move. Right, including comb here. All that's going to go away now. We have this thing called Pokemon moves.py. There you go. Okay, save that. So now what we can do is we can import them. As long as they're all in the same folder, the same directory, I think that's how this works. As long as they're in the same folder, we can import them. So now we can go here, we're going to import random. We're also import Pokemon moves. And we're going to import Pokédex. Right, okay. Interesting. Also, let's go back to our Pokédex here. As you can see in Pokédex, we actually call on Tackle and Combhair. Right there, right? But we don't have them anymore in this document. So let's import Pokemon moves right here as well. Import Pokemon moves. And then now we're going to actually, since we're importing Pokemon moves, we're going to actually refer to these differently now. These are no longer in this document's namespace, it's called, right? We don't define tackle here anymore. There's no tackle here anymore. It's inside Pokemon moves. So now we have to use that ownership thing. You have to use that period, right? That implies ownership. We're going to say Pokemon moves dot tackle and Pokemon moves dot combhair. Right, so we're saying, hey, listen, I want to give this guy a couple moves. I want to use tackle and combhair from Pokemon moves. Right, because we imported Pokemon moves right there. Likewise, we do the same thing down here. Pokemon moves dot tackle and Pokemon moves dot combhair. I think this should work. I could be crazy. I know there's a way to make it more involved. We're not going to get into that today, I don't think. I'm pretty sure if they're in the same directory, they should all be able to run each other as fine. So let's get rid of all this shit right here. Now we don't have a Cyndaquil anymore, right? We have a Pokédex.Cyndaquil. Because now that's defined inside Pokédex, not defined here anymore. And I'm pretty sure that's all we need, right? Everything else here should be fine. Okay, so let's run this and see if it still works. I could be way off base. It could be totally busted. Let's see, tackle. Okay, it works fine. Yeah, so I was right. So let's close this. Oh, let's leave it open, actually. So what we've done here is we've done some packaging. Right? We've done some packaging. We have taken code out of our main document because it's getting kind of long, kind of hard to read. We're taking code out of here, and we moved it to other documents just to make it a little more organized. So now we have this Pokédex. It's only for new Pokemon. And we have this Pokemon moves document. It's only for new moves. Right? And we can import them around and use their code in other documents, but they don't have to all be in the same document, which makes life a little bit easier. So we defined these. I'm going to actually put a comment here. We've defined these two other documents and are importing their stuff. Right. So we defined this Pokédex. It has Pokemon in it. We defined this Pokemon moves list, Pokemon moves document. It has moves in it. So let's make some new moves. Right, so we're going to do our Pokemon moves, right, and define a new move here. So let's see here. Why don't we do, how about we do like Growl, right? It's based on Pokemon move. And it's going to have, a init function. We're going to override init. All it needs is an owner. Let's give it, we're going to call the parent init function, but we're going to call it with the owner we were given, as well as some literals, right? Some literals. We're going to give it Growl as the Pokemon move's name. Is PP is going to be what? Like, I'll give it 10 PP, why not? And it's a normal type move. And when it takes effect, what's it going to do? Well, it will reduce the opponent's attack power, right? So we're going to say, hey, listen, if, you know, target dot attack power is greater than 1. I'm just going to say if it's greater than 0. Right? If they have more than 0 attack power, then reduce their attack power. Target dot attack power equals target dot attack power minus 1. So whatever it was, reduce it by 1. Right? If they have any left. And we're going to print off a message too. Right? Let's just do that. Let's print off, you know, owner.nickname plus growled menacingly at, you know, the target's nickname. As we can say that Zanzu growled menacingly at Dicksucker, right? Hypothetically speaking. Even though he would never do that in real life. I don't think so anyway. All right, and then we can reduce the attack power. Then we can say, you know, if it worked, we'll print off, you know, the target.nickname plus, you know, weakened out of fear. Let's just say, you know, that it backed off, right? It backed off. It'll imply that it got weaker. But we can say else, right? If their attack power was already 0, print target.nickname plus can't get any weaker. Right, so in other words, we're saying, first we say, listen, we growled at them menacingly, and then if they had some attack power left, we lower it and then say that, you know, they backed off. But if they didn't have any attack power left, we say, listen, they can't get any weaker. Right? And there you go, we define a new move. That simple. Right? We just made a brand new Pokemon move. Pretty fucking cool. I see that this is a little bit too long of a line up here. Let me fix that. Wait, is it? Yeah, it is. I'm stupid. There we go. Excellent. Excellent. Okay, so we have Growl now. Let's go try it. Let's go back to our Pokemon list, our Pokedex. And we're going to give Growl to Cyndaquil. So we have this list of moves he has, right? Let's add Growl to it. And let's see here. He's got Tackle, he's got Comb Hair. Let's give him Pokemon moves.growl as well. And now this is so long, it has to kind of get the line broken. So why don't we instead define a list? We're going to call this, you know, move classes equals, he's going to have Pokemon moves.tack, so Pokemon moves.tackle. He's going to have Pokemon moves.comb hair. And he's going to have Pokemon moves.growl. Okay. I'm going to have a message here for Kenny in a minute here. I have a special message for my friend Kenny, but that's in a second. So let's give, we'll call this move classes. And there you go. Probably all fit on one line now, perhaps, huh? Maybe not, actually. Kenny, I got a message for you, dude. For you personally, as my friend. Let's break this line right here. Alright. It's going to be about explicitness in your variable names. But first I want to test this. Make sure it works. So now Cyndaquil should have Growl as well as other moves. Let's go find out if he does. Let's just run our main code. Okay, so what move should Zanzu use? We'll have him use Tackle first. Okay, so Zanzu, Dix just tackled Zanzu, and Zanzu took 6 damage. Let's Growl now. Oh, look, I fucked it up. Owner is not defined. Okay, let's go fix that. I know I did wrong. Let's go to Pokemon moves right here. We don't have an owner variable, right? We have self and we have target. Owner is owned by self. I have to put this right here. Self.owner.nickname. There you go. That should fix that bug. Little typo for you guys. F5. Let's Growl. Oh, I still fucked it up. He doesn't have attack power. What does he have if not attack power? Is it just called attack? Let's go look at our Pokemon class. Pokédex. They have attack, not attack power. I'm sorry. Let's go fix that bug. Pokemon moves. We have to lower his attack, not his attack power. Likewise, we check his attack. If his attack is greater than 0, then we can reduce his attack. There you go. Let's try one more time for the Gipper, dude. Do it for the Gipper, dude. Zanzu, growl! There we go. So Zanzu growled menacingly at Dicksucker. I didn't need a period there. Dicksucker backed off. Growl has 9 PP remaining. Oh, look, I only took 5 damage this time, right? Let's growl again. Oh, he growled at me, that son of a bitch! I forgot he could do that. He picks a move at random. Okay, I thought he could only tackle. They're growling at each other now. We're both growling, fuck. So, you know, Dix has got very low attack power now. I can only do 2 damage. Because I've been losing attack power from my growl. That's pretty cool, right? I'm gonna keep on growling until he's out of attack power. Okay. So now he has 0 attack power. Let's try one more time. Oh, he's still backed off. Oh, because he has more than 0 attack power, right? But he also has defense. Okay. There you go. So now he can't get any weaker. Okay, that's cool. Very, very cool. Okay, so let's talk for a minute about, now that Growl's working, let's talk about variable names and namespaces. What's up, Apollo 1999? That sounds very familiar. I think I have another follower named Apollo. Welcome aboard, dude. We do programming here on Fridays. We are more of a gameplay stream. We stream gameplay 40 hours a week, basically. But on Fridays, we also do programming. Don't get scared off if you see me playing Street Fighter. I also program on Fridays. Welcome back anytime you want to learn more about Python. So let's talk about namespaces and choosing variable names. When you choose a variable name, guys, it should be 2 things. One is short, because you're trying to get as much data on one line as you can, but not at the expense of number 2, readability. Right? So there's a trade-off. There's always a trade-off there in any variable name. You want to make it as readable as possible, while also having it be long. Or excuse me, while being as short as you can get it. That being said, especially for the stream where we're doing like a tutorial, I'm really favoring very long variable names. Right? Like some pretty long names. I'm not really trying to make them too short. I could call it something else aside from available moves, right? It's a pretty long variable name. But I'm opting to instead have it be long and have it be really understandable. At the cost of having to break lines more often, because they're getting pretty long, right? Because all these moves, all these lines have very long variables on them. That being said, in your own code, you have to choose carefully between how short you make it. Like, you want it to be short, but also easy to understand, not just for you, but for other programmers, right? Because somebody else might one day want to learn from your code or help with your code. So definitely use good variable names. Short, but easy to understand. Now, namespaces can make your variables even easier to understand. So basically, if you don't have a period in your variable name, that means that that variable is in the global namespace. Let's talk about that real quick. Let's make a new document about namespaces. Let's make a new document. We're going to call this one namespaces.py and just talk about them in general. Okay. Let's save this as namespaces.py. Okay, so first of all, what is a namespace? Well, a namespace is just what it sounds like. It's a space where you can have a name, right? Let's just say, for instance, this variable equals, bleh, right? It's a string, right? This variable is a string that says bleh. But let's say we want to have another, let's say we want to, let's have, that variable, and it's met. Right? But here's our problem, guys. We want a third variable to be, like blarg, right? Sorry, I misspelled that. Let me go back here. Variable, variable, to be blarg, right? We need a blarg. But here's our problem, guys. Our code, hypothetically speaking, our code relies on blarg to be named this variable. Right? Well, we got a problem now. Right? Our problem is that we already have this variable, and it's bleh, right? But we need bleh. in this example, you know, it's totally hypothetical, by the way. We don't need blet right now, but hypothetically we do. We need blet and we need blarg. Right? Well, here's what we can do, right? We can just say this variable equals blarg, but now we have lost blet. Right? If I print this off right now, you know, print this variable. Then we print that variable. Then we can print off this variable again. Right, let's save this code and run it. Right, if we get ble, we get met, we get blarg. That's because at this point, this variable equals blarg. But what happened to ble? We can't get it anymore, man. Ble's gone, dude. Ble's fucking dead, man. That's because in one namespace, you can only have one variable, one name in that space. Right? You can't have two variables of the same name in that space. Right? There's only space for one of each name. That's the namespace. Right? This is the global namespace. That's because, you know, this is just for our code, right? For our program. There's no, you know, there is no, you know, library dot this variable. There is no, you know, my object dot this variable, right? It's just for the global space. Anything that's just here loose, this is the global namespace. But okay, let's say we have, you know, how come then we can have these Pokemon, right? Let's say we have two Cyndaquils, right? Go to our Pokemon moves, right? Let's go to tackle, right? So in this case, we're reducing the target's HP. It's just called HP, but we have a Zanzu and a Dicksucker. They both have HP. How can they both be called HP then? Right? Why are they both called HP if we can only have one name for each namespace? Well, it's because they're attached to a Pokemon. They're attached to Dicksucker or Zanzu. As you can see here, they have a different namespace. Right? The target has HP, and the owner has HP. They both have nicknames, right? Here you see both nicknames, right? We have an owner, he has a nickname. We have a target, he has a nickname. But because of this this ownership that's involved, that gives it a new namespace because we can just call it target.nickname, right? That's different from owner.nickname, right? They're different in the first half. The first half is different. One says owner, one says target. So it is a different namespace. They're both called nickname, but they are in different namespaces. And not only are namespaces important for reusing names of variables, but they're also important for readability sometimes. Right? So, for instance, let's go back to my... That's why I address Kenny in particular. Is why I'm addressing him. Because he's a beginner learner. He's kind of a lot of us here. He's learning Python. And in a lot of Python examples, I get really... It's a pet peeve of mine. When people are learning Python as beginners, that you will see this a lot. Let's go to Pokédex here. You'll see this code a lot. You'll say, from Pokemon moves, import asterisk. That's how a lot of tutorials start. And what this code right here means, it says, from this library, import everything. But don't just import it into the current namespace. So that way we can save some code. Instead of saying down here, Pokemon moves.tackle, we can say just use tackle. There's up, Labras. We can say just use comb hair. Right? We can say instead of you know, we can get rid of all these things here, right? Because we're not using this names. We're not saying, you know, use Pokemon moves comb hair, right? Because we've imported everything from Pokemon moves into our current namespace. So this is no longer Pokemon moves comb hair. Now it's our comb hair. We made it our own, right? We made all these moves our own. Right? So that's cool. It saves a lot of space. See how much space I just saved? I can put it all on one line now. It was 3 lines before. Look at that. That's really cool, right? We talked before about how when you're naming variables, you want to name them something short so you can have them all be on one line if possible to make them more easy to understand. Right? But here's the problem with from some library, import everything into our namespace. The problem is that it becomes difficult to understand where different things come from. Right? So let's say you have one big Python document that is 1,000 lines long. And I see this. I see move classes, tackle, comb hair, growl. Right? I scroll around. There's nothing called tackle. Where did tackle? There's no tackle. There is no comb here. There's no growl, right? There's nothing here. I've got Pokemon, I've got Cyndaquil, I've got Machamp. And likewise, here's another problem. If we do that for Pokemon moves, let's say we also do it from, from random, import everything. Now, I don't even know. I know that tackle is not defined here. I don't see it, right? So I know that it came from some library. It got imported into our namespace somehow. But did it come from Pokemon moves? Or did it come from random? I have no way of knowing, right? It imports everything into our namespace. So I know it's from our namespace, but I don't know where it originated from. Furthermore, here's another problem. What if I do have a tackle? You know, class tackle inherits from Pokemon. It's a Pokemon it's called a tackle, right? Let's say it's tackle, right? It's Tacklemon, basically, right? If I have a class that's a Pokemon called tackle, and I import everything from Pokemon moves, then down here when I define my tackle, I lose the other tackle, right? Because of namespace limitations, right? We can only have one thing called tackle, right? So my new tackle makes the old tackle go away. That sucks. That's a problem. Oh, well, yeah, Labyrinth, you can do all kinds of crazy hacks to get them back for sure. Let's not talk about too much about that. But yeah, there are hacks you can do to get them back using underscore variables. Yeah, you're right, Labyrinth. It's kind of confusing. Datetime. Datetime is an object and also a library name. It's very confusing. But in the subject of namespaces, I don't know what it is with these tutorials out there that always jump right into this. They always jump right into from library import blank. Don't do that. Please don't do that. Instead, just use import Pokemon moves. I think you're right, Labbers. Programming. So thank you. Yeah, thank you. Yeah, so please do this, guys. Please import the library and then use its namespace to access its stuff. Because that does take a lot more space on the line. Like, a lot more space. It's really fucking annoying, to be honest. Like, how much space it takes. Especially for long library names. I have to break this line up now in a bunch of different lines, right? It kind of sucks. But the benefit is that we know where these came from. Right? We know what library these things came from. And furthermore, we know that we can have our own tackle now. We can have our own comb hair now inside our library and have it not be overwritten or vice versa by importing this other library's stuff. Right, so that's just it's a personal preference of mine to make code more readable. And I want you guys to be aware of the dangers of importing one library's tools into your global namespace. It's not, people do it all the time. It's a personal thing that it's kind of like a pet peeve of mine. But definitely keep in mind, guys, that when you import anything into your global namespace, there are problems that occur. It makes your code harder to understand, and it makes your code a little bit more dangerous because you're overwriting things you might not have realized you were overwriting. What's up, Mumgul Namja? Interesting handle there. This is about Pokemon, dude. We're making a little Pokemon script. As total beginner programmers, we are making our own little version of Pokemon. This is our final day in this lesson. This is our 6th day. On day 1, we started off with the very, very basics of programming about variables and data types and code blocks. But here on day 6, we're doing more advanced stuff. But don't worry, Ninja. Excuse me, Namja, not Ninja. Hey, don't worry, Namja. On next Friday, we're going right back to the very, very basics again, like some day 1 type stuff. Right now, we're on some more advanced topics, but we're really more focused here on beginners most of the time. The Pokemon board, Mungol. Yeah, Python is very exciting. It's a very, very cool language. Are you a programmer, Mungol, or is it your first language? Do you know, like, JavaScript or something like that? Yeah, Labbers, I agree. Python is about readability. I understand you're trying to save space on your line by not having all these library names on your line, but namespaces are a good thing, guys. Namespaces are a very good thing. What do you use, Mungol? Like C++ or C# or something like that? Okay, so we got our code should be working again, right? Let's go make sure our code works. I changed a few things there for the example. Let's run the module. Okay, let's try growling. Oh, Java, nice. Very important language. kind of similar to Python, right? Java and Python are kind of similar because they're both multi-platform. It's just that Python does not need to be compiled like Java does. Java's a little bit faster. Yeah, the main language is Java. It's a pretty good main language, dude. Java is a language that's going to be around for a very long time. Very good professional language. Alright, so everything here should work. Thank you for the follow. Stress test. Interesting handle there. Stress test. Okay, so let's close this. We had this namespace example, right? We learned about the global namespace. So what I'm trying to get at, guys, is that... I'm sorry, I didn't mean to kill that. Here. Oh, look at... I lost some program. I lost some... Well, I closed the wrong thing. That's why. Poop. Let's just open then. Let's file open day 6. There we go. Ta-da! Close that. And move this over now. There you go. We're at 1,000? Wow. Let's go. We got 1,000 followers. Wow. What a milestone. Thank you, Stress Test, for being the 1,000th follower, I guess. Okay, guys, so Pokemon, our code works right now, right? So we're basically focusing on improving it. Here's what I'm thinking, guys. We were working on adding new moves. Right, so now we've got Tackle, Comb Hair, and Growl. Why don't we add in another class? Like, how about we add in, like, Flamethrower? Flamethrower. Yeah, we'll just have it called Flamethrower like this. And it extends Pokemon move. It is a Pokemon move. Let's go, Stress Test! You're that dude, man. What an honor, right? You can put that on your resume. Vencabot's 1,000th follower. And just like other Pokemon moves, the first thing it does is it overrides a init from its parent. And all it does is it runs its parent's version of a init with some custom variables. We're going to call this one Flamethrower as its name. We're going to give it less PP than Tackle has. We're going to give it like 5. As I'm thinking Labrys. We might have time for that. We might have time for like conditions and that kind of thing. I have some ideas first though. Let's add some new moves first of all. It's going to be a fire type move. All right, that's pretty cool. Fire type move. All right, now we're going to say, you know, def take effect. It's going to have a target. And we're going to call this, you know, what it'll do for it'll say print off, you know, self.owner.nickname plus blue flames at plus target.nickname. Actually, might fit on one line. There you go. Then we're going to say, you know, if target.element type, right? That's what the Pokemon have, right? They have an element type, I think. Let's go double check. The Pokédex. They have an elemental type. Okay, they have an elemental type. So we're saying, hey, listen, if their elemental type is equal to grass, we're doing big fucking damage, man. We're going to say actual damage equals, you know, our owner's attack power times 2 minus their defense, right? The target's defense. All right, so we're getting a double attack power if it's super effective. And we're going to print off. We're going to say print it's super effective. We're going to say, you know, otherwise, you know, if they're not grass type, just do normal damage. So actual damage is, you know, self.owner.attack power minus target defense. Right. So we're saying, hey, listen, do regular ass damage unless they have a grass type, in which case it's super effective. Do double damage or close to double damage, right? Pretty cool. Very simple little thing there. We don't have a grass type. Let's go make a grass type Pokemon to test it on, right? What should we use, guys? What's a good grass type? Here's our Pokedex. Let's say, you know, class. I don't know. What should we use? Oddish, Bulbasaur. Should we make one up? A new Pokemon? Make a new Pokemon. Let's call it Ganja. Ganja. What's up, Faust? Give him a nickname. So we're gonna make a new Pokemon. It's gonna run its parents init. And it's gonna run that with whatever its nickname is, as well as the name Ganja, that's its type, its monster type. It's gonna be a grass type. And what should it have? Well, it should have, you know, pretty low HP. Right. That's what I'm thinking. We'll give it, like, let's see here. So Cyndaquil has 55 HP, and Machamp is 88, or has 80. Let's give him somewhere, you know, around, maybe even less than Cyndaquil. Let's give him, like 48 HP. Right. And we'll give him, you know, pretty low attack power. We'll give him, like, you know, 5 attack power. Then we'll give him high defense. Right. He's just totally impenetrable, dude. He's totally impenetrable. We'll give him, like, so Machamp has 6, and Cyndaquil has 2. We'll give this guy, like a 5. He's a little bit less than Machamp, but much more than Cyndaquil. More than double Cyndaquil's. Then we're going to give him, you know, his move classes. Right. We haven't defined that yet. There you go. So what moves should he have? What moves should Ganja have? Well, let's give, let's just say, you know, move classes. We'll give him tackle. You know, Pokemon moves.tackle. We'll give him, we don't need any growl. He's not going to be that. We can give him comb hair. Right. But he's not going to give him growl. He's not that aggressive. We should make a new move for him, right? What move would Ganja have? Some kind of grass type move. Let's make a new move for Ganja. Back to our Pokemon moves list. Some kind of Vine Whip. I don't know. Yeah, like a Vine Whip. We'll give him Vine Whip, but we'll give him like a custom move too. We'll make a brand new move for him. So we have to actually have Flamethrower reduced to health, right? So I have to say here 1, 2, 3, 4. 1, 2, 3, 4. We figured out what the damage is supposed to be. Let's just say now that you know, target.hp equals target.hp minus the damage we're supposed to do. And we're going to print off how much health they have left, right? So we're going to say you know, target.nickname plus took plus the string version of actual damage, that's an integer right now, plus damage. All right, break a line here. Then we're going to print off how much health he has left. Print target.nickname plus has plus the string version of its HP. Target HP plus, you know, HP remaining. There you go. And there you have it. Okay. So we did this move Flamethrower, now it does some pretty good damage. That's fine. Let's define Vine Whip. It's going to be basically the same thing as Flamethrower. What's up, Labyrinth? What did I do? Something wrong? String.format argument. I know, Labyrinth. We're not going to talk about that just yet. Right now we're still adding strings together, so people can see how string adding works. But yeah, good idea, Labyrinth. Yeah, if you know how to format strings using the format function, or even using Python 3's brand new, glorious F strings. Oh, they're so fucking good, dude. F strings are so godlike. But if you know how to use those, you don't have to add strings together like this. It's kind of a pain in the ass to add all these strings together. But I want to do this for now to kind of drive home that numbers can be added, but so can strings in Python. You know, F strings libraries. Oh my god, so good. Yeah, I can save a lot of space that way. It's a lot more fun than doing it this way, but this way is kind of more beginner friendly for now. So we have, you know, let's copy-paste Flamethrower. We're going to call it Vine Whip, though. But basically, it's going to behave the same way as Flamethrower does. Right? It's called Vine Whip. We're going to call it Vine Whip. Just like Flamethrower, it's going to have 5 PP. Unlike Flamethrower, it's going to be a grass-type move, not fire-type. And let's see here. We're going to change its dialogue here. We're going to say, instead of blue flames, that we're going to say whip to vine at. We have to break the line now, actually. Okay. And we're going to say, hey, listen, if their elemental type is, grass is good against, what in Pokemon? Grass beats rock, I think, and ground. Is, rock. Or, if target elemental type is equal to ground, Let's actually break this line. It's getting pretty long. Then do super effective damage. Right. But we're gonna also say elif, because unlike flame, I think that grass is actually weak to some things. Or am I wrong about that? No, I'm not sure grass is actually. Let's not fuck with that yet. Gotta break those long lines, Lapras. Pep 8, dude. Pep 8. Okay, so we're saying, hey, listen, if the opponent is a rock type or a ground type, do super effective damage. Otherwise, do normal damage. Right. So aside from that, it's basically the same thing as a flamethrower. But let's give this guy a really cool move. I have a really cool idea. Right. Let's say we're gonna say class. How about light. We'll call this light. It's going to be a move called light. Pokemon move. Alright, it's going to inherit from his parent, but we're going to override init. We're going to give a call to parents init method. We're going to call this move light. And it's going to have, we're going to give it, how about just only 3 PP? Very, very low PP on this move. And it's going to be a grass type move. Right, and its effect, we're going to say print self.owner.nickname plus lit up. Right. We'll call it light up, actually. We'll call it light up. That's better than just light. Right. When he lights up, he let's say that his self.owner. Oh, thank you. Oh, yeah, not 2, just 1. Thank you, Kenny. Self.owner. Let's give him more defense, right, when he lights up. So his defense equals self.owner.defense plus 1. You can only use it 3 times, though, so he doesn't get a whole lot of defense out of it. In fact, let's actually do it plus 2. Give him really high defense when he lights up. Okay, so we have another very simple move here. All it does is raise his defense by 2 when he uses it. Let's go back to our Pokédex. We're going to give Ganja, he's going to have Tackle, Comb Hair. Going to give him Vine Whip. And we're going to give him Light Up. There you go. So let's go back here to our actual combat, our Pokemon Day 6. Let's make a Pokemon 3. Right. Equals, we'll call him, he'll be Pokédex. He'll be a Ganja. Vine Whip. Not Vine Whip. Oh, okay, thank you. Go fix that. Yeah, you're right. You're right. So let's see here. Vine Whip. There it is. So that's over there on the Pokédex. There you go. All right. Let's go back to our Pokemon moves. Excuse me, into the Pokemon combat Day 6 here. Okay, so we're gonna give a Ganja, and he's gonna be named, I don't know, man. We're gonna call him. What's a good name for a Ganja? I'll call him Locust. Right. So now we can, we'll say that right here. We'll say, Combatant A is Pokemon 3, and Combatant B is Pokemon, we'll have him fight Dix, Pokemon 2. Alright, so we're going to say, if Combatant A's health, we're going to change some things around here, so we can swap Pokemon easier in our combat. Right, and then Combatant B also has to be alive. Okay, what move should Combatant A's nickname? And Combatant A's monster type. Actually, let's print off his moves here as well, because we have more different kind of move types. You're just sending Combatant B to their death. Oh no. Ain't that tough, Dix. Ain't that tough. Okay, let's see here. Let's go, you know, print available moves. And we're going to say, you know, for move instance in combatant A's moveDict.values. We're going to say print 1, 2, 3, 4 plus move instance move name. There you go. And look at Dix now. Dude, you're going to be fine, Dix. You're going to be fine, dude. Oh, yeah, you're saying that, yeah, Dick Sucker is dead. You're right. This is the ghost of Dick Sucker. Long live Dick Zucker. But Dick Sucker is dead. Let's see here. So let's print a blank line as well. And there you go. We have a list of available moves. Use one of these moves. Okay, we're going to say, instead of Pokemon A, we're going to say combatant, Pokemon 1, we're going to say combatant A. Right. On combatant B. Right. Just change some things around. Just change some variables around here, so it's easier to swap our Pokemon around in combat. Before we had to kind of do it, we had it kind of hardwired in. Right now, make it a little more flexible. Right. Instead of Pokemon 2 now, directly we're saying combatant B, and combatant B could be anybody. Whereas Pokemon 2 is a certain Pokemon. And combatant B. Okay, change this one right here as well. Okay, blah, blah, blah. Probably forgot one of these. I might even do a search to make sure I didn't forget anything. Okay. Okay, I guess we have to do this. That'll do. Use this on combatant A. Yay! Okay, so let's see here. So winner is combatant A. If combatant A has health remaining. Otherwise, combatant B is the winner. This is a one line. We'll talk about this in a minute. I forgot about this line, guys. Let's talk about this. The loser is going to be a combatant B if the winner is a combatant A. Stands to reason, right? Otherwise, the loser is combatant A. There you go. Okay, guys, so let's just do this fight real quick, see if it works. Okay, I'm going to do a quick search here. That's Control F, right? Let's do a search for Pokemon 1. Make sure we got all of them. Okay, that's good. Let's try Pokemon 2. Okay, good. So we got all of them. So Pokemon 1, 2, 3, those are all instantiated objects of the Pokemon classes exactly. Combatant A and Combatant B are only just referred to those same instances exactly, K, right? Yes. So let's talk about, variables, right? Now, in some languages, at a high level, variables don't perform exactly the same way across languages. Now, at a low level for beginners, you could definitely understand that variables work the same in Python, in JavaScript, in Java, in C++, and C#. It's all the same. They always work the same way. It's just a name for a value. But some languages have what they call pointers, which behave a bit differently. Whereas in Python, we should be very clear here that when we say Pokemon 3, it's just a name for this object. Right? It's just a name for this object we made here. This instance in this case, right? Of Pokemon, of Ganja. And when we say, combatant A equals Pokemon 3, we're not saying that, if I were to say after this, let's say I change this to, let's say that I changed Pokemon 3 right here, right? Equals, a new thing. Let's make it a Machamp, right? It's going to be called, Vencabot, obviously. I'm a champ, right? That does not mean that combatant A is now Machamp, right? Because, yeah, I changed Pokemon 3 to Machamp, right? And combatant A is Pokemon 3, right? So you think maybe it'd be Machamp. But no, what we're saying here is this evaluates, right? This evaluates to whatever it is at the time. So we're saying combatant A equals Pokemon 3. In real time, Python is saying, well, who's Pokemon 3? Okay, Pokemon 3 is Ganja. Okay, that means it equals Ganja. Right? We're not saying combatant A is whoever Pokemon 3 is forever. It's just when the assignment happens that's who combatant A becomes. Now, in some languages, you have what's called a pointer. And a pointer behaves the opposite way. A pointer would say, hey, whatever this points to, this is going to always be changing, right? It's going to always be changing. But no, this is set in stone right here. As far as Python is concerned, combatant A is, locust. Locust to ganja. Because that's who he was at assignment time. If we change who Pokemon 3 is now, it doesn't matter anymore. Combatant A is still locust. Right? It doesn't matter if it's Vencabot. Pokemon 3 is Vencabot. Because it evaluates during assignment. Here's where the assignment happens. This is when combatant A gets defined. Okay, I'm sorry, guys. There's a little bit of a rant there. Because there's a problem that Kenny had earlier on our Discord server. Yeah, it can be kind of confusing. Yeah, when you assign a variable in Python, it evaluates everything down to their basest of values. Right? All the references get dereferenced. They get evaluated basically. You don't save references anywhere. A little bit advanced. They can cause a problem later on if you're not aware of it. Okay, so let's run this. Run it. I'm sorry, I fucked something up there. Oh, I need to put HP right here. This is what line? Line 18? Right here, I'm stupid. So we have to figure out if their HP, not if they're greater than 0, if their HP is greater than 0.
Duh.
Sorry, guys.
Duh.
So what move should Locust to Ganja use? Well, where is it supposed to print off? Oh, it's an input. I have to print it off beforehand. I'm stupid. Here, let's say, right here, we're going to say, excuse me, combatant A dot nickname plus moves. We're going to say Locust's moves. And it prints off. So let's actually let's add his type as well. Plus the plus combatant A dot monster type. And we're going to add a plus like this. We actually knock this down by a line. That'll do. Let's make sure this is indented right. Let me see here. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, we're indented correctly. And let's just change this line now to say, what move should so-and-so use? That'll do. Okay, so I'm going to put this below now. If it wasn't clear, guys, we didn't get our move list because we have it printed off after we ask for input. If I were to input a move right here, right now, in fact, let's do it, in fact. Let's go back here to our shell. I'm going to put in, like, tackle. Then we get a move list after we tackle, right? Which makes no sense. We want to see the move list before we put a move in. Let's move all this stuff. Let's move the prompt a little bit lower. Yeah, dum-dum. Dum-dum-dum-dum. There we go. So now when we get a new turn, it prints off the list of moves. Then it asks us what move we want to use. That makes more sense, right? Okay, let's also make this a little bit taller. Because we're going to need more space to see our moves and stuff. Alright, so we save this and run this again. Okay, so Locust to Ganja's moves are Tackle, Comb Hair, Vine Whip, and Light Up. What move should Locust use? Well, let's start off simple with Tackle. Okay, so Locust to Ganja tackled Dicksucker the Cyndaquil. Okay, so Dicksucker took 3 damage. And he has 52 health remaining. Okay, I got 9 more PP for Tackle. Tackle has 9 remaining. We gotta fix that typo. Let's go fix that right now, right? That's over there in the Pokédex. On Use. Excuse me, it's on Use. I'm sorry, that's a Pokemon move, right? Not Pokédex. Right here. Use on. It has PP remaining. Not remaining. There you go. We also need a plus right here. That should be a period. There you go. Fix some typos there. Okay, let's go back to this. What should I use now? Let's use Comb Hair. Make sure that works. Okay, so Locust had to combs its hair. I got 0 P. Let's try Comb Hair again. Oh, I got a PP error. Oh, it's not defined. Oh. Here's a problem, guys. On line 11 in Pokemon moves, it says raise PP error. That's not in our namespace anymore, guys. It's not. But it stands to reason that should be in this, it should be in Pokemon moves anyway, right? Because PP error occurs in Pokemon moves. So let's copy that from here, from our day 6 up here. We have this class, PP error. It's a very simple class. I'm going to explain that in a second here. Or review it, I should say. Let's review that error. Okay. There you go. Very simple class. So, pass in Python is a statement. It's built into Python. It's kind of like continue, right? Or raise, right? It's just it's a statement. It says pass. What pass does is it does nothing. Its whole function is to make indenting work in Python, right? So let's say that I want to let's make a pass example here. Make a new file. Right. Let's save this as pass example. Right. So, you know, pass is a statement you can use when you want to do nothing, right? But what's weird about that is that you can do nothing by typing nothing, right? So let's say that, you know, print after this, we're doing nothing. Right. Nothing fucking happens here. Right, let's save this and run it. See what happens, guys. What do you think is going to happen here? Okay, well, after this we're doing nothing, then nothing happens. Makes sense, right? Because nothing happened down here. I mean, I could say, you know, print, you know, oh shit, it's happening. Alright? And now something happens, we type something down there. Very simple, right? So what good is pass? And why would you want to pass if you can just do, if you don't give any instructions, then, you know, nothing happens, right? Well, that's because pass satisfies indentation, right? So let's say you have a class, right? A class such as PP error. But when you define a class, you have to have indented code afterward. Well, you can't just have nothing because it needs to have something indented afterward, right? There's nothing there, there's nothing to indent. So pass gives you something to indent. It just says don't do anything. That's really all it does. So in our example over here, we could say, you know, our pass, let's just say, you know, make a new variable up here called, you know, do nothing. And it equals, you know, true. Let's just say it equals false. Right. So let's say here, after this, are we doing nothing? And we can say, you know, if do nothing, then pass. Else, do something. Right. So in this case, we want to do nothing based on an if statement, a condition. And for that reason, we have to indent some code. We have to use a code block, right? And because we're indenting, we can't just have nothing, right? Because we have to have code there. It's an if statement. It has to have code indented. So pass satisfies that same requirement. That's really all pass is for. It says just don't do anything. What's up, Arksum? How you doing, man? All right, so let's run this code now. F5. So, oh shit, it's happening, because do nothing is false. Let's make it true. All right, so now I should do nothing, right? Last time I did something. Let's see if now it'll do nothing. Okay, see, now it does nothing. Right? Nothing happens afterward because we said do nothing to true. So if do nothing, then pass. Otherwise, print a statement. So here in our Pokemon moves, we have this class PP error, and what it does is it inherits from exception. So it has all the things exception has, right? And when you define a class that inherits, such as tackle inherits Pokemon move, right? So does comb hair, etc. You can override some methods. Right? So we're overriding init. We're overriding take effect. And you can also add new features as well if you want. You can inherit your parent stuff and then also add new features. But here in PP error, we just want to rename exception. Right? We don't really need to override anything, nor do we need special functionality. We just need another error with a certain name, so we can catch it in particular. So you'll oftentimes see things that inherit exception. They don't override anything or add new features. They just pass. Right? So I'm just making a new error. It's called PP error. It inherits from exception. That's all that it does. It inherits from exception. You're done. Pass. So now we have PP error in there. That's all well and good. But we have another problem, guys. We have a problem over here in Pokemon Day 6 now. We removed PP error is gone. Right? But we also check for it right here. We say except PP error. But we don't have that anymore. So now we have to say Pokemon moves.pp error. There you go. Easy. We're saying use Pokemon moves PP air. That's it, we're done. So, cool. Let's run it and see if it works. Run module. I want you to use comb hair, my dude. Let me type that in here. Use comb hair. Alright, so we combed his hair. Now he has no PP left. Let's try comb hair again. So comb hair has no remaining PP, and then it asked me again what move to use. Perfect. That's what we wanted, right? It reports it has no PP, and then it asked me again for a move to use. Let's try light up. Okay, so it says here, Locust lit up. Light up has 2 PP remaining. Okay, cool. So I have more defense now, right? Oh, look, I took less damage. See? I have more defense now. I'm light up again. And now he can't damage me at all. My defense is too high to take damage anymore. Sick. I'm a god. Let's also Vine Whip. Make sure that works. Okay, so I used Vine Whip. Okay, I whipped a vine at Dicksucker. He took 3 damage. All right, well, it's supposed to do more damage though if he's ground type, right? Let's make a new Pokemon. Let's make a new Pokemon. We'll call him Geodude. He's a rock type, right? Let's go to our Pokédex, and we're going to make a new Pokemon. He's going to be Geodude. We're going to override a knit real quick with a nickname we could be provided. Let's say, you know, moves classes. Let's call it move class, not moves classes. Move classes is just going to be, he's going to have tackle. That's all he's going to have. What a scrub. Pokemon moves dot tackle. That's all these got going for him. And we're going to, you know, we're going to get the nickname put into the new Pokemon we're making, as well as its type, which is going to be Geodude. It's going to be a rock elemental type. And it's going to have, you know, a good amount of HP. We'll give it like, you know, more than Cyndaquil. We'll give it like 60. Pretty good defense. Not as much as Machamp, though. We'll give it like, you know, like 12. Pretty, really high defense, really. That's its attack power. Attack power should be, you know, around the same as Cyndaquil. And its defense should be, like, really high. So, Machamp has 6. We're going to give this guy 6 defense, even though he's a, you know, a rank 1 Pokemon. Oh, and then he's going to have his move classes as well. Cool. There you go. We made a Geodude that quick. That's why classes are so strong, right? Classes are so strong because we can just inherit from Pokemon, and it has all these cool features built in right away. Right? You can already use moves. It already has moves, right? Just from inheriting from Pokemon. All we're really doing is just defining what makes a Geodude different from a regular Pokemon. That's to say it's a Geodude, it's a rock type, and has these stats, right? And certain moves of its own. There you go. So it kind of makes it a lot easier to make new Pokemon. We just make all kinds of, you know, hundreds if we wanted to. Why not? In fact, that's exactly what Pokemon Company does in real life. They have a Pokemon class, and they make new Pokemon pretty easily by swapping variables in and out, and by drawing them. Right? They make a little sprite for each one. Or a nice modern-day Pokemon character model. In our case, we're just all text-based, so it's pretty easy. Okay, so we have a Geodude now. Let's see if it's super effective against him. Right? Vine Whip. Let's go back to our Pokedex. Excuse me, to our Pokemon Day 6. And we're going to say Pokemon 4, we'll make him a Geodude. Pokemon 4 is Pokedex.Geodude, and his nickname could be what? What to be a Geodude? Arxum? You're a Geodude now, dude. I'm sorry. That's your fate. Now we're going to say our opponent is going to be a Geodude. So now we got a Ganja versus a Geodude. Locust to Ganja versus Arxum the Geodude. Let's run this code. What should Locust use? Well, let's tackle him first. Okay, so he took 0 damage. I can't even do enough damage to hurt him with tackle, because my attack power is so low and his defense is so high. Right, he's a Geodude. But if I use Vine Whip, it should be super effective, right? That's almost double damage. Let's try that. Vine Whip. Okay, so Locust whipped a Vine at Arxum. It's super effective. Arxum took 4 damage. Nice. So Vine Whip does damage because it's super effective. Wow. Quick and easy, man. Quick and easy. This game is getting pretty complex. I see a typo there, though. It didn't have a period after the let's go back here to Pokemon moves for Vine Whip. Right right here. Whipped a vine at so-and-so's name. Gotta add a period at the end of the sentence. There you go. Probably up here, the same problem, right? At Flamethrower. blue flames at so-and-so. We have to actually put a period there. Which means line breaks. Okay. There you go. Alright guys, we got the new Pokemon, we got some new moves. That's pretty neat. But let's before we move on any further, why don't we look at our Pokemon Day 6. I kind of glossed over this, but it's a new concept for the stream. And that is this line right here. This is a pretty complex assignment, right? Winner equals combatant A if combatant A to HP is greater than 0, else combatant B. This is a single line conditional statement. Now before we've looked at if, right? Which is, it's an if, then a statement, and then you put a colon afterward, and then if that statement is true, then the indented code will run. Right? We learned about else, right? Else happens after an if, and that code block is indented and only runs if the if statement was not true. So it's like a fork in the road, right? Do this if true, otherwise do that. Right? It's like a little fork. But you can also do an inline conditional statement for assignment especially. It's really strong for assignments. So here we're saying return this value if the condition is true, else return this value, right? So look at this line here. We're saying the winner is combatant A if combatant A HP is greater than 0. So if at the end of the fight he's still alive, then combatant A is winner. Else, so if his health is 0 or lower, then give us combatant B instead. So that would say, winner is combatant B. And here we say loser is combatant B if winner is combatant A. Right? So is a, it's actually different in meaning than equals equals. Here you see equals equals, right? Equals equals means is equivalent to. So we're saying, hey, if your the number of available moves is equivalent to 0, so that could be none, right? None could be equivalent to 0. And also 0 is equivalent to 0. Then do this. But is means that it has to be the same exact. Is for when you have two variables, and it says, are they pointing toward the same thing? So 0 is you can have a ton of zeros, right? Let's make an example here. Make a new document here called is example. Let's go here. So let's save this as is example. .py. So you can have my 0 equals 0, and your 0 equals 0. Right? They're all 0. You could have any number of zeros. We could have a third 0, and it's a 0. Now, it could be full of shit. I think these are not going to be the same thing. Let me actually do before I even give you guys some false information, let me say, if my 0 is your 0, print, they're the same 0. Right, but I don't think they are. Let me run this code here. Maybe I'm wrong about that. Oh, they are the same 0. Okay, I'm wrong about that. But let me how about strings? I think maybe strings won't work. My string equals blah. Your string equals blah. Then third string is blah. Let's say, is my string your string? I could be wrong, but I don't think it is. But if it is, I'll have to explain. I still understand it, how it works, but let's see here. Oh, they are still the same 0. Okay. So I guess literals are the same thing. But basically, for the case of a literal, I guess, like a literal like blah or like 0, I guess that Python treats them as being a one of a kind. Right? So a 1 is always a 1. They're all the same 1 as far as Python is concerned. They all point to the same idea of 1. Likewise, I guess blah always points toward the same idea of blah. Right? But there are some situations where, let's try this for instance. Let's try, my list equals red, blue, yellow. And then your list equals red, blue, yellow. Right. I'm pretty sure that my list isn't your list. I'm almost certain of that. Let's say print they're the same list. Right. Let's try this. Okay, so they're not the same list. Let's just say else, right? Else, print, they're not the same list. But let's also print off, you'll say, you know, if my list equals your, I'm pretty sure that they're equivalent. Print, they are equivalent lists. Else, print, they're not equivalent lists. So let's run this. Okay, so in this case, we have two lists, right? Let's get rid of all these strings here. You have my list and your list. They have the same stuff in them, and they're the same length, right? So, despite the fact that they have the same length and the same stuff in them, they are not the same list. They're two different lists as far as Python is concerned internally, because they can both be changed, right? They can both be changed different ways. So they are independent lists, even though they're equivalent. In fact, we look at our output here, you will see that as far as Python is concerned, they are equivalent lists. So this statement is true. My list does equal your list for now. But if I change one of them, they would not be equivalent anymore. Right? So right now they're equivalent, but they are not the same list. So that's why over here I can get away with this. If I go back to the day 6 code, I say if the winner is combatant A. I'm not saying if it's equivalent to combatant. I'm not saying if the combatant, if the winner is a Pokemon who has the same stats and the same type, etc., as combatant A. I'm saying they have to be pointing to the exact same Pokemon. It has to be the same guy. Right? So is even more specific than equals is. Right? Equals says, hey, they're equivalent. Right? They equate to the same thing. But is means it's the same exact object in memory. And apparently, I guess that's true of singletons. A singleton means it's a literal that points toward the same memory space in Python, right? So I guess integers and strings, their literals, are technically singletons. They point toward, as long as they're the same thing, they point toward that same space in memory. I didn't know that before, but there you go. But yeah, so is just very specific. It says that these two things point to the same exact object in memory, whereas equals just means that they're equivalent. They're pretty much the same. So it's your inline if statement. I just want to cover that real quick about how this line works. We hadn't done that before on the stream previously, but it's kind of complex. It's a good way to save lines if you're into that kind of thing. The static variables. Static variables. They're not a huge thing in Python. They do exist though. But yeah, that would definitely be a matter for is, for sure, if you want to do it that way. Okay, so let me close this pass example and the is example. Okay, so now we have about half an hour left here on the stream to just sort of play around. I want to stress, guys, because I'm new to the channel here, this is our 6th and final day of our Pokemon example. We started off with the most basic of ideas for programmers that have never programmed before in their lives. I'm talking about what is a variable. What does it mean to add two variables together? What is an if statement? Right, that was our day 1. If you want to check that out, it's on YouTube, guys. Go to youtube.com/Vencabot archive. You can go watch that stream in its entirety, as well as get the script for it on our GitHub. It's at github.com/Vencabot/intro_to_Python. So intro to Python on GitHub. Go check that out if you're into that kind of thing. That's a great way to learn Python if it's your first day programming anything in your life. Right? And then with every day that we added to this Pokemon script, we added in more complex ideas. But we learned a little bit more about looping, a little more about different kinds of code blocks, a little bit more about different kinds of data types, right? And finally, we got to classes, which are a pretty complex idea of the way classes work, you know, attributes and methods and inheritance and that kind of thing. But that's because right now we are kind of intermediate level, maybe even encroaching into advanced ideas in programming. But this is our last day doing this. So on next Friday, we're going back to total beginner stuff, like it's your first day programming anything in your life. That's going to be a new example based on an adventure game, no more Pokemon. It's going to be like a little adventure game, like we solve puzzles and stuff. And that will be again on next Friday, guys. Don't get too freaked out by all this advanced, these advanced ideas. We're still focused mostly on beginners here. But in this case, it being our last day, I figured I'd kind of go a little bit wild and add some new features to our game, including the ability to level up, for instance, right? Why don't we level up our guys? So to level up a Pokemon, you need, here's what I'm thinking you need, right? You need a couple things. You need an EXP that they can drop, and you need to store that EXP somewhere. Just go to our Pokedex and go back to our Pokemon, our base Pokemon. Let's give them some new values. Why don't we rename some of his? We'll give him some new attributes, right? How about we give them a base HP for when he's level 1? Right. Let's do it like this. So he has base HP now, right? And he has base attack when he's a baby. We'll call this base HP. This is base attack. We're gonna actually change these variable names up here. Now you're supplying a base HP. You're supplying base attack. You're supplying base defense. This means it's a level 1 Pokemon. And there you go. So he's got base HP, he's got base attack, he's got base defense. Okay. But also, he has some new attributes, right? He has a move list, sure. But he also has, how about, what if he had a level? Right, so we're going to say, you know, self.level. He starts off at level 1. Right? And how about self.exp? Starts at 0. He has no experience. Let's call it experience. Vine Whip. We got Vine Whip, dude. We got Vine Whip programmed in. Alright, so now he's got experience and he's got a level. Why don't we say, like, self.exp to next level? And it should start off at, you know, how about just it starts off at, like 50. Right, so he's 50 XP level up. That's true of any Pokemon right now, right? Cool. Alright. So, we have to code around that now, right? Let's actually make him level up a little bit. So let's go back to our fighting code in the actual main script. Right? And now when he wins or loses, and when he wins, he should get experience points, right? Well, let's fucking do that. Right, let's go down here to where it says winner or loser. Right? We'll say print off so-and-so's the winner. Now let's give him some EXP. Let's say, you know, let's give him some EXP like the hard way right now, like a hard-coded in. We'll say winner dot experience equals winner dot experience plus let's just give him 30. Right. Then we'll say we'll print it off, you know. Winner dot nickname plus earned. We'll just give it. I'll just say we'll earn 30 experience, right? You earn 30 experience points for winning. Right. So we calculate that right there. Then we'll say if winner dot experience. We'll call it. Let's change the name of this. Actually, let's change the name of this line right here from EXP to next level to EXP required. 4 level. Right. There you go. Let's go back to our Pokemon day 6. So we say, hey, listen, if the experience the winner has now is greater than or equal to the winner's EXP required to level, or is it 4 level? I'm sorry, I already forgot. Required 4 level. Okay. So hey, listen, if he's at or above his XP he needs for his level up, give him a level up. Right? We'll print, you know, winner dot nickname plus leveled up. Right? Then we're going to give him a level up. Right? So that means that winner dot level equals winner dot level plus 1. Then we're going to say winner dot HP equals winner dot HP plus winner dot base HP. So it's base HP is how much it gets per level. That's how Pokemon works, more or less. Your level 1 stats get added to your stats each time you level up. Winner dot attack equals winner dot attack plus winner.base attack, and winner.defense equals winner.defense plus their base defense. And then we'll say, you know, winner, we'll make it simple for now. Winner.exp required for level equals winner.exp required for level plus 50. We'll make it simple for now. Just goes up by 50 every single time. That's kind of not really how most RPGs would work, but for now that's how it works. Okay, so now they can level up and get stronger. All right, we have a problem right away, right? Before we even run the code, we already have a problem. That is to say that we finish the fight, we see who's the winner, we give them experience points, and then maybe they level up, maybe they level up, maybe they don't. But either way, the program ends right there. Right? So, why don't we instead make another fight happen? Well, how do we do that? We have to make some kind of loop, right? Well, let's put this loop, right? That this is one fight, into another loop where another fight happens. Right? That means a lot of indenting, though, right? How can we solve that problem? How can we not indent all this shit? Well, here's how you do it, guys. Why don't we make a new function? Right, to make things simple here, we'll call this function, you know, Pokemon battle between combatant A and combatant B. Just apply 2 Pokemon for it, right? And what this does is it does all this shit right here. So we actually simplify this. Why don't we do this like so? We'll instead of adding, we'll actually subtract indentations. We'll say we'll call this battle turn. Battle turn, combatant A and combatant B. So what you do here is you take all this code right here, and you copy it, put it in this battle turn code. There you go. Right, cool beans. And then what you can do is you can go down here to this while loop. Get rid of all of it, like all of it, literally. And you can just say, you know, while the combatants are still alive. I didn't even get it all. There you go. No, I did get it all. Here it is. So while they're still alive, do battle turn combatant A and combatant B. There you go. Let's make sure it works. Oh, not properly in loop. Oh, these parts here, we go back to the top of the loop. Well, it's okay. We just need to break instead of continuing. Excuse me. Use return. So the reason why there's got an error message here is because we say continue on this line right here. Continue. But then there's no loop, right? Because this is the loop actually happens down here. But we can do those. We just end the function, which you can do by using return. So return ends the function. It'll end battle turn, which has the same effect in this case of continue. Okay. So if these conditions become true, if these the error conditions become true, just end the function, and then it'll loop back again anyway. Because right here it'll loop back again when the function's over. So technically, we could just use a single class Pokemon and take the values from a DB or a CSV to contain all Pokemon by ID exactly, Arcsum, yes indeed, if that's your fancy. In this case, we're focusing entirely on Python, pure Python Arcsum, so there would be no databases here yet. Probably not in the near future either, but indeed you definitely could. You would definitely have your Pokemon types, instead of saving them as classes in Python, you could save them as a list of related data in a database, or like I said, a CSV. Either way is totally fine. Because really all we're doing, we're not, so I guess what you're trying to say, Arcsum, is that, let me go back to my Pokédex here. So we talked before about classes, right? And how in classes you can do 2 things. You can override methods, and you can add attributes, like custom methods and attributes, right? You can override your parents' stuff, or you can also add your own specialized stuff. Right? So Cyndaquil could have his own cool stuff that's unique to Cyndaquil, right? He doesn't have to have all the things Pokemon has. He could have some of his own cool stuff, but in this case, he does not, In this case, all we really do is we override a init, right? And all we really do by overriding a init is run our parents init with some custom data. So this is a perfect example of when you might want to use a database or something like that in DDarksome, because we're not really adding a whole lot of functionality here to Cyndaquil. He has no new functionality, right? He just has his own data. So a database would definitely be something you could definitely do for sure, Arksome. You could definitely do that if you wanted to. In this example, if that would please us. In our case, we're focusing on pure Python. That means we're going to be using just Python data types, not using database type stuff. Okay, so let's go back to our Pokemon Day 6, right? Let's run this code now. HP's not defined where. Oh, it's in... Oh, okay, it's in line 11 of the Pokedex. I guess I'm going to typo here, guys. I apologize. Oh, yeah. It has to equal base HP. I'm sorry. And attack has to equal base attack. Because we don't have an attack anymore. We have base attack now. We have base defense. There you go. I'm stupid. Okay, let's run this code one more time. One more time. Okay, so we got Locust here. Everything should be fine, I think. Let's have him use Vine Whip. Okay, so what happened here is I got a turn, then he got a turn, and then I got asked again for a turn. Right, and that's exactly why, that's because here we have our battle while loop, or here's our while loop for our battle. And it just runs this function. Battle, let's call it battle turns, actually. We got 2 turns here, for the combatant and for the other combatant. Right. So we were able to migrate all this code for the actual combat into its own function. That makes it a lot easier to indent and change indent later on. Right, we can indent this, 1, 2, 3, 4 more, or we can do it indent with less, depending on how our code evolves. So part of writing your program is not just functional. It's not just making a list of instructions. It's making it more readable and more manageable. And in that case, sometimes defining functions just to move data around, just to move your code around to make it more accessible for you, is pretty important. In our case, we just moved this big combat code into a function up here. So now we can do more down here. We have more space to work, basically. So our goal here is to have one battle end, then have another battle start. Right? So here's what we're going to do. We're going to say, while combatant A dot HP is greater than 0. So as long as Pokemon, our Pokemon is alive, then start a fight. Right. Oh, I thought I had an awesome idea. Here's what we're going to do, guys. We'll make a list of opponents, like a gauntlet. Let's do that. So let's say that combatant A is Pokemon 3. That's Ganja, right? Then we'll say opponents equals, it's a list. Pokemon 1, Pokemon 2, and Pokemon 4. Right, so all the other Pokemon are the opponents, right? Now we can say for, combatant B in opponents. So for every Pokemon in that list, they become Pokemon B for a while, right? For the course of this single rotation of this loop. Then we can say, hey, listen, while combatant A is alive and B is alive, well, let's print a message. We'll print off, combatant B dot nickname plus the plus combatant B dot monster type. So Zanzu the Cyndaquil plus appears. Appears. 1, 2, 3, 4. Let's go over here and knock this down a line so we don't have all these scrolling going on. Then we'll say print. It looks pissed off. Right, so it appears and looks pissed off. And then we say, as long as our guy is still alive, or as long as our Pokemon is still alive, and as long as our opponent is still alive, then have them fight. Right? And after every single fight, we're going to actually indent this now. After every single fight, determine a winner and a loser, print a message, and then dole out experience points. I'm actually going to move this, just for sensibility's sake, move this on top. We're going to print a statement, then we're going to give the EXP out. There you go. Actually going to have to indent this now. And there you go. Okay, so let's look at how our code has changed. We only changed a few lines, but we added so much functionality. Right? So now instead of having a static combatant B, we have a list of opponents to go through. And then for every opponent in that list, they become combatant B until they die. Once that fight's over, we go to the next opponent. So then we get experience points whenever we win, and we can even level up. Let's see if we can, if this works at all. Okay, well, it works right off the bat. So it says, Zanzu, the Cyndaquil appears. It looks pissed off. Okay, so I can choose a move. I have to beat Zanzu. He doesn't have any fire-type moves, thankfully. We never give Cyndaquil a flamethrower. Let's try hitting him with tackle. Okay. Oh, he growled at me. Fuck. See, now we actually have more strategy, right? Because now if I lose my attack power, I can't get it back. Oof, that's a pretty rough to start off with here. I do so little damage, in fact, with my tackle and stuff, that he probably will lower my attack power to nothing before I can even kill him. Okay, he tried to comb his hair. Okay, thankfully I got a free turn there. Oh, I'm doing such little damage. I can't beat him. So we have to rebalance our game a little bit. It's pretty cool, though, right? I mean, we're kind of like actually doing some game dev now. So our problem is that our level 1 attack power is so low that it can get reduced to 0 very quickly. The problem is that we have too much HP, right? All of our guys have too much HP compared to their attack power. That makes the fights too long. So let's fix that right now. Now we're having fun. Let's go to our Pokédex. So basically at level 1, we don't need to have as much HP as we do, right? Why does Cyndaquil have 55 HP at level 1? He only does, he has 8 attack power, right? Let's instead give him like, 24 health. He dies in 3 tackles now, right? From another level 1. Yeah, let's actually, yeah, that's fine. Then we're going to give Machamp at level 1. He doesn't need 80 fucking health. We'll give him, like, 40 health. That's pretty steep even then. And for attack power, he doesn't need 20. If he's going to try and kill another Machamp with the same level, that would mean he would hit him, we'll give him, like, 3 times to kill him, approximately, right? So we'll give it, like, like 13 attack power. He can kill another Machamp in 3 turns. Or the same level with 3 tackles. Okay. And then his defense, well, I have to change the defense now, too, right? Well, 2 is fine. And 6 defense, it's a little bit high. But I think it's still okay. Because they have more attack power now than before. Or they have lower health. No, they have the same attack power but lower health. All right. Well, Machamp is invincible to a lot of Pokemon now. He has too much defense. But they're level 1, and he's a Machamp. Let's make one adjustment here. How about Growl will not reduce your attack power to 0? Well, even that wouldn't help because of the way the defense works. Oh, I got an idea. Let's change the way that the damage calculation works. Okay, let's go to Pokemon moves, right? Moves that do damage are Tackle, Flamethrower, and Vine Whip. Here's Tackle. We're going to say, hey, listen, if actual damage equals is less than 0, or 0, say less than or equal to 0, make it 1. So now you can never do 0 damage. You can only do 1 damage to the lowest. All right, let's change that down here, too. So for Flamethrower, hey, listen. If the actual damage is, but I never did fix this, right? I have to make sure it's not 0. Let's just say, if actual damage is less than or equal to 0, then actual damage equals 1. Right, same for Vine Whip. If the actual damage is less than or equal to 0, then make sure it's 1. Okay, so for now, let's not do too much balancing. Let's just go fix the Pokemon in the most basic of ways. By just lowering, they have too much health. They have too much health in general. The fights take too long. So Machamp, he's got 40 health now. That's pretty high, but he's a Machamp, right? 13 defense, 13 attack power, pretty high. 6 is fine. So let's just lower their health. So Ganja, instead of having 48, let's give you like 28. And Geodude, instead of having 60 health, will give you, like, 32. You have more health than most. Being a Geodude now. Let's try this fight now. See if this is more manageable. Alright. Also, let's make the fights in a random order. Wouldn't that be fun? Let's go to the Pokemon Day 6. And we're going to say, instead of having 4, opponents in that list, 4, loop over that list, we'll just say, let's see here. How about... Well, we can sort the list randomly, right? How do we do that? Is there a library for that? Put them in a random order. Let's see, does random do that? Let's see here. Seed, get state, set state, rand range. Element from range. No, I don't want that. Rand int, don't care. Choices. Returns a k-sized list of elements chosen from the population with a replacement. Okay. Alright. A k-sized list of elements chosen from the population. So I think I want choices what I want. Or shuffle. Shuffle, that's what I want. Yeah, shuffle them in place. Yeah, that's a lot simpler. So we can do random.shuffle. It shuffles the list in place. We get the same list, but its elements are reorganized. Let's go back to Pokédex, Pokemon Day 6. Opponents equals that list. We're actually going to random.shuffle that list. Do I actually have access to random here? I think I do, right? I'm sure I do. There you go. Oh, no, because it shuffles them in place. It actually doesn't copy them. Let's just do that. And then we'll say, opponents equals random.shuffle opponents. There we go. Perfect. Actually, it would have worked fine either way, but that's fine. I'm stupid. This is the way it is. Okay, so let's run this. We should have random opponents now, like a random ordering of the opponents. Oh, none of it's not iterable. What? In opponents. Why is he getting a none type? Let me print off a diagnostic message here. Print off opponents. What is opponents now? Oh, it returns none. I'm sorry, I'm stupid. So we don't actually have to assign. Because it does it in place. So we can just do it like this. So what happened there, guys, was that when you run random.shuffle, it returns none. Because it's not actually, it doesn't return the list. It just moves the list's objects around in place. So we're talking about mutability here, right? It's mutability. The list itself is mutable, so it moves the stuff in place, and then now opponents is, reordered. But it doesn't return anything, so that was my problem there. All right, let's run this code. There we go. So now I'm fighting Arcs from the Geodude. That's a bad first draw, except that Geodude is weak to Vine Whip. Also, I should light up, because if I light up 3 times, I get more defense. Let's light up first. Okay. Oh, I got higher defense now. Let's go. Okay, light up again. And light up again. So now I have no PP left. Let's try running it one more time. Okay, I got no PP left. Okay, cool. But I have really high defense now, so he can't do any more than 1 damage to me. Let's Vine Whip his ass. Okay, super effective. Took 4 damage. Very high defense in this guy. Okay. Boy, he's got a lot of health. Okay, Vine Whip. Vine Whip. And Vine Whip. Boy, he's got very low PP. Oh, but I still can't kill him. Because his defense is too high for me to hit with my tackle. So I got a bad roll. No, I can do 1 damage now per tackle. But he has 12 health. I only have 10 tackles on me. I don't have Growl. No, I've got Comb Hair. Fuck. I can't beat this guy if I draw him first. That's fine. Let's just reload it. Let's reload it. Okay, let's see here. So now I got a Zanzu first. Okay. He doesn't have a flamethrower, even though he's a Cyndaquil. I never gave it to him. So let's start up with Light Up to get more defense. Oh, he lowered my attack power, you son of a bitch! Alright, tackle him. I'm only doing 1 damage now because fucking his I can't kill him either. So Growl is so strong at early levels. Right? It's so strong at early levels because it reduces your attack power by 1. So if I draw Zanzu first or Geodude first, I'm in a pretty, or even Dix. So I can't beat any of these guys. I can't beat him with Ganja. So I'll pick Geodude instead. So combatant A is going to be Pokemon 4 now, and my opponent will be Pokemon 3. So we're actually swapping over to Arxum now. Let's do it this way. So we're swapping out. We're changing Pokemon now away from Locust to Arxum. There you go. So I only have Tackle. That's fine. Just tackle him. So Tackle Cyndaquil. Okay, he took 6 damage with a lot of attack power. I can kill him in 2 more tackles. Well, I guess I can't do math. In 2 more tackles now. Here we go. 1 more. Okay, so let's see here. So I got experience points. And then Zanzu appeared. Actually, let me put a line break there. Right, there we go. So let's go down here and print a blank line. Nice. So here's the problem I have, right? I have limited PP. So, let me go to Pokédex, excuse me, to the script here. So I'm running out of PP now. I only have Tackle. And I gotta kill Zanzu. But I got 6 tackle. I could probably do it. I got pretty high attack power. Let's just do it. Tackle. He has Growl, though. Let's see what happens. He combed his hair. Nice. Wasted his turn. Okay. Tackle him. Okay. Tackle him. Okay, he's at 6 health. I can kill him with 1 more hit. He didn't growl. Thank God he didn't growl. And tackle. Hey, I leveled up, see? So I got 30 experience points, and I leveled up. So my health got restored because of a bug. I didn't talk about this before. I noticed it, though. That we calculate our HP based on how much health we have remaining, and we apply our base health. So I actually restore that much health when I get a level up. That's kind of cool. But I think I don't have enough attack power. Actually, my attack power doubled. So I can probably kill somebody even though I'm low on PP. I only have 2 PP left. Who does fight? Oh, Locust appeared. He's got kind of high health, though. Let's try. See how much damage I do now. He has high defense, too. Yeah, I did 11 damage. But, yeah, he has 17 health remaining. I attack 1 more time. Oh, he got a Vine Whip, too. Super effective. I have very high defense, though, so not much you can do. I leveled up, so I have more defense now. Okay. Yeah, I can't. I'm out of PP, though. Yeah, so I can't. The fight's over. I didn't program in struggle yet, so I can't finish the fight. But guys, I think we're gonna call it quits there for now. I was kind of hoping I'd have more time to add more functionality to this, but as a tutorial, we're done with Pokemon. Right? At this point, I'm just making my own fun features, not really going into detail about how they work. As a tutor for you guys, I have explained what I wanted to explain with this project. We went through all the basic stuff. We went through, again, variables, data and operations, and how they're both halves of the programming spectrum. We talked about code blocks, like logical code blocks, like if, else, elif. We talked about how loops work with while and for, some statements like continue and pass, return. We talked about functions and how we define functions and why, and their arguments, their return values. We discussed classes and how to define them and why you would define them. We talked about attributes and methods and that sort of thing. We really got some pretty advanced ideas toward the end here. Our game is really cool now. Again, for a beginner project, it's still got a lot of work to do on it for sure. But as a total beginner project, it's a really cool little thing. We actually fight more than 1 Pokemon in a row. We can level up and get stronger. It's kind of cool, actually. It's kind of really cool. We discussed libraries, how to import new features from libraries and that kind of thing. We even made our own libraries, which is kind of nice. But next week on Friday, guys, we're going to start a whole new project back to day 1. If you guys are kind of feeling overwhelmed right now, don't fret. On Friday, it's going to be back to basics with Notepad and talking about what is a variable, what is a conditional statement, how do we use them. Right, we're going to talk about code blocks again, like about why do you indent code sometimes? How does code flow from top to bottom? How does it work? Right, and then we're going to go back into very gradually introducing functions. We'll introduce some loops. We'll introduce some classes again eventually. But we're going to go right back to the day 1, straight out of the cradle, trying to program our first ever code, which is going to be an adventure game next time, kind of like Zork. We're going to walk around a house and try and use a key to open up a door and have treasure chests and stuff and that kind of thing eventually. But it's going to start off very simple. But in this case, guys, I'm pretty proud of how this turned out. We got Pokemon, we got a Pokédex, we got, we can make them with different names and stuff and have different fights, randomized stuff. It's actually kind of cool. We actually work on this. If we had like 2 more streams of this, we actually have a pretty cool game on our hands here. But you guys can finish it for me, right? It's going to be on GitHub very soon. Probably in like 2 or 3 nights. It'll be on GitHub. It'll be on YouTube as well. You can go rewatch this episode. Pretty cool. Guys, as usual, if you enjoy a hangout, want to keep the channel online, check out my Patreon page at patreon.com/Vencabot. Even a buck is a huge help. Goes a long way toward making the channel more sustainable in the long term. Put the taco in my belly. It's very helpful stuff. Also, you can help for free by following on Twitch. Tell your friends we're here. Save clips if you want to. Not really a programming, but more of like gameplay here. We play gameplay most of the time here. There's a bones just in time for the end of the stream. We're going to be actually playing some Sonic R now. The end of the Python stream, that is. We're finishing Python and moving on to Sonic R. How's your day been, Bones? Also, you can help for free by checking our YouTube channel at youtube.com/VencabotArchive. That's youtube.com/VencabotArchive. I have all of my past streams archived there, including lots more intro to Python. You can go watch my earlier episodes there, where it's much simpler. Said earlier on, it's much simpler. It's again the real basic type stuff. And you can see how we got to this point, which is a little more advanced. Also, we have got gameplay there, like long plays, retro games, modern games, horror games, shooting games, adventure games, AAA games, and indie games, online and single-player games. It's a lot of gameplay, all painstakingly organized by game, in playlists, as well as by genre. It's pretty well organized over there. I'm pretty proud of that. We're going to go for a short break, guys. Come right back with Sonic R on Sega Saturn, my childhood favorite game, well, one of my favorites. It's kind of a whack game, but it's kind of fun to make fun of and look back on as an adult. I'll be right back, guys. Don't go nowhere. I'll see you guys very shortly. Open another restaurant? So wait. I'm not sure I understand, Bones. You got, what, are you opening it as a manager, or are you opening it like as like an owner? Or do you mean opening it as you get moved around by your parent company to help open stores? 'Cause that sucks. The latter sucks. No, I'm sorry, Bones. That does suck. Yeah, I did that back when I worked at Meijer back in the day. They had me move between different Meijer stores to help open them, which is like a huge pain in the ass. Yeah, Meijer's like a Walmart, basically. Got scouted. Well, it'll be a change of scenery anyway, right? How far away is this place? In my case, it was like a fucking hour drive away from my house. They're stunned. Got a round here. No Chaos Dunk Plus. 20-minute walk, 5-minute drive. Okay, that's convenient. Hey, Dios mío. It's kind of a drag. You have to work with other people too, like people you don't know. As a manager, it seems like it could be weird. You have to kind of meet new employees, and you're not sure how to work with them yet. Kind of learn their personalities and what works best for them. How long are you gonna be there? Like 2 weeks, something like that, or a week? I'm happy to hear that, Bones. Oh, you started 2 days ago. Okay. Holy shit! We're getting somewhere as of today, though. All the new floors are done. Wiring and plumbing is finished. Wow, that sounds even more stressful than I expected. In my case, I was working as like a grunt level employee. They had me help open the new store before they could hire in more laborers. So I basically did my normal job, but in a new location with new people. In your case, it sounds like you have to do a lot of interesting responsibilities, like for working with the contractors and shit. Probably not something you oftentimes do.